Education is not the learning of facts, but the training of the mind to think. Albert Einstein. Good morning, everyone. With great pleasure, we welcome you all to the day 3 of ATAL Basic Faculty Development Program on Mastering the Frontier of Artificial Intelligence, Trends, Challenges, and Applications. It is an honor to introduce our esteemed speaker, Dr. V. Sushila Devi, Principal Research Scientist at Indian Institute of Science, Bangalore, from the Department of Computer Science and Automation. She earned her PhD from IISc in 2000. Madam's research expertise includes machine learning, deep learning, artificial intelligence, and soft computing. Dr. V. Sushila Devi has made notable contributions to machine learning and AI, reflected in her numerous research publications encompassing of journal articles, conference proceedings, and book chapters. Her work has been cited widely, and she has actively contributed to advancing knowledge in her field through her research and mentorship. Beyond her research, Dr. Devi has been actively involved in academia, guiding students and delivering lectures in her areas of expertise. Ma'am, we are privileged to have you among us. I would like to invite Dr. Mary Jacob, Coordinator at ATAL FDP, to welcome our speaker, Dr. Sushila Devi, with a sapling.
Thank you.
Thank you, ma'am. Now I request Dr. Sushila Devi to take over the session.
Yeah. You have to point it to this one. No. No. Okay, thank you. Okay, good morning, everyone. I'm basically going to talk about how deep learning can be used in the field of artificial intelligence. Earlier there was only machine learning. Okay, there was no such thing as deep learning. Okay, there was only neural networks, right? So the neural networks, limited use was there of neural networks. Okay, so it could be used only for numerical inputs, basically. Okay, so you have to give numerical input, and it had only one layer or two layer of nodes. I don't know if all of you are familiar with neural networks, right? I hope you all are familiar with neural networks. Okay, so it was very limited. Okay, so when deep learning came up, okay, so what was done is that the input which was given to the deep learning systems, the modes went up. Okay, so you could give an image, you could give sound, you could give text. It wasn't just numerical input. Okay, so because of that, you find that it's very suitable for artificial intelligence type of problems. Okay, so I will go through the type of problems you can do basically with deep learning. Okay, so first of all, uh, what is artificial intelligence? Okay, so I'm sure everybody is talking about what is artificial intelligence. So basically, you're trying to make the computer do what a human being can do. Okay, in other words, what is considered intelligent when a human being does. Okay, so that job, how do you make the computer do that type of a job? Okay, so there are two ways you can go about this. Okay, one is to actually mimic what the human being does. Another is that you make the computer to do the same thing by using some computational processes, right? So those are the two ways in which you can make a computer do artificial intelligence basically. Okay, so so this thing, if you see, study of making computers do things which at the moment people do better, okay, this actually keeps changing, okay. So if you take, say, 1950s, when the computer first came, right, at that time, even doing things like adding numbers or multiplying numbers was considered to be something very great, right? And you found that the computer could do that much better than the human being could do. But as time progresses, okay, you find that this definition keeps changing because we have said at the moment, right? So now if you see a computer doing addition or multiplication of huge numbers, you don't consider it to be intelligent at all. But I'm sure when it first did it, it was considered to be something intelligent, right? So obviously intelligence is what you can think of over here, right? So how do you go about in AI, okay, making in artificial intelligence, how do you make it do intelligent things? Okay, so there are things like, of course, you have the hardware-oriented thing. Okay, so you need to have something like, sensory perceptions. Okay, like you have cameras and you have, infrared finders, etc. Right? A number of different sensors are used. Okay, so that's the hardware part of it. Okay, and also if you look at an agent. Okay, so when you talk about an agent, you say that it does something. Okay, so you have some input which comes to it. It takes that input and it processes it and carries out some output. Okay, so there you talk about motors, etc., which carry out the job. Okay, so that will go into things like robotics, etc. So we are not going into that basically. Okay, we are just going into the computer science part of it. Okay, that's the basic thing we are doing. So what is it that we do in AI is use things like machine learning to do the learning, expert systems, and things like reasoning, okay, problem solving, and so many things like that, right? So all these techniques together, okay, form artificial intelligence, basically, okay. So if we want to put a formal definition, it's some form of intelligence. You are making the computer do some form of intelligence, basically. Okay. Okay, so you have a number of definitions given in different places, right? Dealing with the simulation of intelligent behavior, okay, and capability of machine to imitate intelligent human behavior, okay, to perform tasks commonly associated with intelligent beings, etc. Okay, and theory of how the human mind works, right? So that will be something like introspection. Okay, so when you do something, you sort of introspect to see what your mind is actually going through at that point in time, right? So that is what you call the computational intelligence, right? So all these things actually go into artificial intelligence, okay? So now, having just set the stage and seen what artificial intelligence is, we'll go into deep learning. Why is it suitable for artificial intelligence? Okay, we already had machine learning, we had so many things, right? Now, why is it that the deep learning is suitable, more suitable, okay? It brings AI to a much higher level, okay, than what we had before, okay? So let us look at why we need to use deep learning, okay, for artificial intelligence. First of all, you can add analysis of images, speech, natural language processing, and so many other types of data types into it. Okay, so that makes it into another level. Okay. Um, Another thing is that you don't need to find the features. Okay, if you take any machine learning algorithm, you need to actually manually find the features which you are going to use in that machine learning algorithm. Okay, now those features are very important, right? If you don't use the right type of features, then you won't be able to have a very efficient machine learning algorithm. Okay, so the features are very important there, and they have to be done manually, right? And you have to say manually we need to have so many classes, okay, and these are the features that we are going to use, okay. So there may be some features which are redundant, right? So if you put those features into it, okay, then it won't help you to sort of distinguish between the various classes. So what you want is you want meaningful features, okay. So what happens in the deep learning method is that it automatically finds the features, okay. The features are extracted automatically. In other words, feature engineering is done by the deep learning method itself, right? But it needs to be done separately as far as other machine learning algorithms are concerned. Okay, so that is one important thing. Another thing is that it makes sense of unstructured data. Okay, for example, you can have a document, right? And you want to take that document and you want to summarize it, right? So that document is unstructured, okay? So you don't have data like you generally have, this feature has this value, this feature has this value, etc. You just have a number of sentences forming a document, right? So that is like unstructured data, okay? So structured data is something like your database, okay? You have a database, okay? And you say you have so many attributes, and each attribute takes these values for each of the records, etc. Okay, so we don't need that type of data here. We can use unstructured data. Another thing is that as soon as we started using machine learning, obviously machine learning requires a lot more computational processes taking place, and also you need a lot of data, right? But the results that you're getting is extremely accurate, okay? You find that the accuracy went up like anything, right? It wasn't just a small improvement from machine learning algorithms, okay? As soon as they started doing deep learning algorithms, you found that the accuracy went up like anything. And we know that in AI, especially when you're talking about things like, say, medical field, etc., right? You need to have very accurate results. Okay, so the accuracy is very important. It should be almost close to 100%. In many cases, in say a medical diagnosis or something, making a wrong diagnosis is going to be very difficult, right? Wrong diagnosis means it requires intervention of doctors also to see whether the right diagnosis is being done or the wrong diagnosis is being done, etc. So the higher your accuracy is, okay, the better it is. Okay, so you find that since you're getting a much higher accuracy using deep learning methods, okay, so you can see if you look at the title of this talk, right, how you can harness deep learning for AI, right? So these are some of the factors which you need to consider here, okay? So this is how you have it. So you can say that deep learning is a subset of machine learning, right? So in machine learning, you have basically even neural networks, okay? And neural networks enhancement, okay, if you take the neural network and enhance it so that you have so many number of levels, you are going to get deep learning, right? So deep learning is a specialized subset of machine learning, which is a subset of artificial intelligence, basically. Okay, so this is the way you get the Venn diagram. Okay, so now if we look at feature engineering, okay, so we can see that feature engineering is very important for machine learning, okay, and it should be designed manually, okay, um, and it is an art, okay. So in other words, you have to use your intuition and you should decide these are the features which are important, right? And if your features are wrong, your prediction is going to be wrong, however good your machine learning algorithm is, okay. And you can see that all these different things go into finding the features, okay. First of all, you will have something called feature extraction, where you are going to extract a whole lot of features, right? Out of those features, you have to remove unnecessary and redundant features, and you may have to create new features. How do you create new features? Either you combine, transform, okay, use features from the context, etc., right? Um, and you may have to modify some features, okay, some from binary to numeric or numeric to binary, or maybe if it is increasing, if your original feature is x, you may have to use 1 by x as a feature, okay, that type of thing, okay. So if you do all these things, okay, this is the process of feature engineering, which is also a very big job, okay. So what we do basically is that in the field of research, we just take data sets which are already available, right? So in that data sets, they've already done the feature engineering, okay? So we don't bother to do feature engineering. We just take it. Not only that, they've also done the pre-processing. So you don't do pre-processing, okay? So because of that, we don't get understanding of this, but you know, this is what needs to be done when you're trying to find a machine learning algorithm from scratch for something which you're doing, okay? You may have collected the data yourself, right, for a particular domain, okay? Then you need to carry out feature engineering. You may have to do scaling of the features. You may have to do pre-processing. Okay, so many things are there. And all these things are unnecessary when it comes to deep learning. So that's the point which I wanted to make over here, right? So better features means flexibility, because if you're using the right features, your machine learning algorithm may become very easy. Okay, you don't need to have more complicated learning going on, simpler models and better results, right? So here you can see that in the case of machine learning algorithms, you need to have this extra thing done over here, right? Whereas in the deep learning, the features are got automatically by your deep learning algorithm, basically. Okay, so what is that? What is it we are doing in deep learning? Okay, and why is it that it is better? Okay, let us see that. Okay, first of all, it means a neural network with several layers of nodes. Okay, so you have levels, right? And in neural network, we allow only 2 hidden layers, right, in between. Okay. Yeah, so it's like this. You can have one more layer. Okay, that's all. In other words, you have the input layer. You have one hidden set of nodes. You can have another hidden set of nodes. Then you need to have the output. So that's how your neural network is. Okay. But here, what do? We have a number of layers. Okay. Now, what happens is that the problem with doing this is that we cannot use the same updation formula for the weights like we use in the case of neural networks. Okay? Because the weights will get smaller and smaller and smaller. Okay? You're starting from the end and you're going backwards. And you find that you have what is called the vanishing gradient problem. In other words, it'll come down to zero, okay, almost. and then you won't be able to update the weights. So you need to have a new method for updating the weights of a deep learning method. Okay. So these are the characteristics we need to see, feature engineering. And what you find is that when you have many levels, the lower levels features, okay, will combine together, and as you keep going deeper into the neural network, you find that higher level features are found. Okay. So for example, if it is say a face or something, at the first level you may have only pixels, right? And as you keep going, the feature could be something like the nose, okay, or the eye, or the complete face, etc. Okay, so that's what we mean by a higher level feature. Okay, and the problem is in training many layers, okay, which is what we need to see over here. Okay, so how do we train these many layers? Okay, so that's where we need to see how this is different from the usual neural network that we have, right? So what you do is, so basically, you are going to first train this layer, okay? And once you train this layer, you get these nodes, okay? And you're going to use that to train this layer, okay? And you use that to train this layer, okay? Then you train this layer, train this layer, and finally you're going to train this final, this is the classification part, okay? So that's how you're going to do this basically. Okay, so how do you train each of them? Okay, so this is trained to be an autoencoder. Okay, autoencoder means you have an encoder. If you consider an encoder and a decoder, okay, so you have encoder. This is the encoder. Then you have a decoder, right? Now, if the output is the same as the input, okay, you consider this hidden layer having less number of nodes, right? So when it has less number of nodes, you're saying the output is the same as the input, okay? And you're going to train the weights in this network, okay? So once you do that, these nodes, the hidden nodes, since the nodes are less, it's going to represent the same thing as the input or the output here, okay? But it's going to have less number of nodes. So you have reduced that to less number of nodes, okay? So what you're going to do is that your network that you're going to have, okay, you're taking these fewer nodes to be the nodes in the next layer, right? So you're using each level is like a encoder of this encoder decoder, right? So you find that in each level the features are becoming higher and higher level basically, okay? So each of the intermediate level is trained to be an autoencoder basically, okay? And once you do that, in the final layer, you are going to do the classification by using these higher level features which you have at the last level, basically. Okay. So these are different types of deep learning networks. Okay. So basically, we will consider this deep neural network. So in this deep neural network, this is exactly like a neural network, except that you have more number of layers, right? So you can see the problem here is you have too many connections, right? And if you have so many connections, then the computational burden also goes up, right? So that is what you need to take into account. This of course is a encoder, this is the encoder, this is the decoder, etc. There are different ways, okay? So let us, I just want put this to show you how there are different types of networks. Okay, so what is a deep learning algorithm? It's a class of machine learning techniques that exploit many layers of information, okay? And if you look at the second one, it's for learning multiple levels of representation in order to model complex relationships. Higher level features and concepts are defined in terms of lower levels ones. Okay, so you have a hierarchy of features basically, and that is what is called the deep architecture. Okay, and you can see that it's been introduced with the objective of moving machine learning closer to artificial intelligence, basically. Okay, so that is another definition you can think of. One is, of course, by using higher level features. Another is also by using different modes, right? You have images. So let us see how that is done. Okay. So we know that in the neural network, you can only give in numerical inputs, right? Now, how do we give in inputs like sound, images, all those things, right? So that is what we have to see here. Okay, so some deep learning networks, okay, deep belief networks, then we have RNN, recurrent neural network, convolution neural network. So some of the deep learning architectures, right? And you have things like generative learning. So in generative learning, you're generating networks. For example, if you have a set of images, how do you generate new images, right? So we'll leave it at that. And supervised learning is for discriminating power. In other words, how do you classify the input? Okay, that's the um, second one. And third one is what is called the hybrid deep networks. So for example, you have what is called the generative adversarial networks, where you're using um, the discriminative ability to carry out generation. So this is what is called the hybrid network. So these are the three types of networks that we will have. Okay. So what are the ones we'll study today, right? On a very brief basis. We will first talk about the convolution neural network, which is the most popular network which is there. And then we'll talk about RNN, and we'll talk about generative adversarial networks, which is a generative thing. And finally, we'll talk about transformers, right? So these are the four types we are going to study. So what you find is in deep learning also, you find that if you keep looking at it over the years, okay, you find that first you had things like CNN, RNN, etc. Before that you had the deep neural network which I showed you earlier, right, with many layers, etc. And later on we came to GANs, okay, and finally we've come to transformers, and transformers give you the best result out of all these different types of methods that we have. Okay. So let us look at some of the tasks which you can carry out using deep learning. Okay, so because these are very important, because these are things which you could not do in the other machine learning algorithms basically. Okay, so you can do text classification, language modeling, machine translation. That is, you can say convert Hindi to English, English to Hindi, etc. Document summarization, which I told you about. You have a document, you can summarize it. Okay. There are two types of summarization. One is abstractive summarization, where you just take the sentences from the original document itself. Or you can have summarization where you form new sentences, right? So those are two types. And you have question answering. Okay. So you have a document. So if you ask questions on that document, it will tell you, give you answers on that, right? So these are some of the applications for natural language processing. Then you have things like speech recognition, speech synthesis, machine translation. So you have speech in one language, you convert it to another language, right? So if you have something in English, you convert it to speech in Hindi or some such thing, right? So these are some of the tasks that we have. And when we come to images, you have things like image classification, scene labeling. So what are the different parts of the scene, okay, which you have? For example, if it's a remote sense data of a particular area, okay, this gives some crop, growing, this is the road, okay, that type of thing. Image captioning. Okay, so what is image captioning? You have an image, you give a caption for that image. Okay, for example, the caption could be a cat sitting on a chair or some such thing, right? So looking at the picture, it should extract the meaning of that, and it should give a caption to that. Okay, so that also involves NLP, because the caption has to be in NLP, right? Then human face detection. So whose face is this? Okay, you have a number of people's faces. You should be able to recognize whose face it is. This is made more difficult because you can have a person facing forward, you can have a person facing sideways or at different angles, etc. Right? Action detection. When you come to videos, you have something called action detection. Then pose detection. Okay, is it a side face, and at what angle is the face, etc. Right? And saliency detection, what are the parts of the image which are important, right? And image detection, etc. Okay, so these are all some problems in images. Okay, now if you come to data sets, okay, you find that lot of data sets are available, okay, for deep learning algorithms. So you find that many people just use the ready-made data sets which are available online, right? So, so you have data sets for images, speech, NLP, etc. And the thing about data sets for deep learning is that they have to be really big, okay? Because you need to have a lot of data to be able to get a right answer for deep learning algorithms, okay? So we can say it took off now because we know that there's a lot of data available nowadays which has been collected over the years, and also the computational power also has improved over the years, right? So both these things have added up to make it easier to do deep learning, okay? Especially with things like cloud storage and using cloud for your computation, etc. You find that, especially you find that big companies like Google, etc., they have a lot of computational power. So you find deep learning is done much more by, organizations like these. Okay, so they come up with more number of algorithms, etc. Right? So you find that this website gives you a collection of different deep learning data sets, and you also have image and speech data sets in this particular website. Okay, so you can, if you are doing research, you can look up these and find data sets to use. Okay, so I am looking at some image data sets. Okay, so first of all, you have ImageNet. Okay, it has 14 million labeled images with 2000 categories. Okay, so each image is just one object. Okay, so you have things like balloon, strawberry, etc. Right? So these are some of the images that you have in ImageNet basically. Okay, another one is what is called the Minutes data set. So the Minutes data set has handwritten digits 0 to 9. Okay, it has a training set of 60,000 and a test set of 10,000 examples, right? And it's all been pre-processed. Okay, so you have pre-processed data available. In other words, it's all centered. Okay, and the angle is also done properly. Okay, so that you can compare images easily, etc. Okay, so you have fixed size and size normalized, etc. Another is CIFAR 10 dataset. This one actually is very popular. Okay, many people use these images. So there are 10 classes. Okay, with 60,000 images for each class, right? So you have things like bird, cat, deer, dog, etc. Right? So here we have this which is not very clear. Of course, there is some problem with these images, but at the same time, the images that you get in the CIFAR data set is also not very clear. Okay, and But it's found that the discrimination between them is easy, like it can be done, right? Another one is called the COCO data set. Okay, so this is for segmentation of objects. Okay, so you have an image and you need to segment. Okay, especially when it comes to things like medical images, right? So you have things like ultrasound, etc. So how do you separate the say the cancerous part from the non-cancerous part, etc. Okay, so segmentation is a very important concept. Okay, in this. So here they have actually segmented the images for you, okay, so that you can get better segmentation. So you see this has been segmented. You find that different objects in these have been segmented and given different color coding, etc. Okay, so those are to help you to work on segmentation algorithms basically. Okay. Then you have what is called the visual question answering data set. Again, this is both images as well as NLP, right? So you have images, and with the images, who is wearing glasses? Okay, you have a image which is given you and which has been given to you, and you have a question called who is wearing glasses. So the idea is to find out, to be able to give the right answer, right, for all these type of questions. So for every question there are three images, there are three questions, etc. And when you give an answer, you can check out whether it's right or not. Okay, that's for the evaluation of your algorithm. Okay, so this is another data set which is available to you. Then we need NLP data sets. Okay, the one which is used a lot is what is called the IMDb data set. Okay, this is a movie data set. So you have movie reviews, okay, and using these movie reviews, they carry out what is called the sentiment analysis. Okay, binary sentiment analysis means that is it a positive review or a negative review. Okay, in some places when you do sentiment analysis, you have more number of classes, right? You can have positive, negative, neutral, or you can have other sentiments also, if you consider. Okay, so this is an example of a movie called Bromwell High. Okay, and this is the review for that. So like this, you will have reviews. Okay, and you can use that for sentiment classification. Then you have what is called the 20 news group, okay, which has messages from 20 news groups. Okay, so you can use this for classification. Okay, for example, if you have something which appears in the newspaper, you can see is it coming from politics or is it coming from sports, okay, etc., entertainment, that type of thing. Another sentiment, a sentiment 140 data set where you have tweets. Okay, so a tweet is actually confined to something like 140 characters. Okay, and you take the tweet and you see whether it's a positive tweet or a negative tweet, etc. Okay, so this is another sentiment analysis. Then you have WordNet, which is very highly used, right? So you have what are called synsets. So synset is a group of synonyms. Okay, so one word you may have another word which means the same thing, etc. They are all called synsets, right? Then you have what is called the Wikipedia corpus, which consists of so many articles, etc. Okay, which is taken from Wikipedia, obviously. Okay, you can take a Wikipedia dump and you can take out the information from there. Okay, so these are some data sets. Then we have the speech data sets. Okay, so one thing about these data sets is when you get these data sets, since people use these data sets itself for their research, you can see for this data set what is the state of the art performance, right? And you can see whether you can find an algorithm which improves that, right? So that's the basic idea when you do research, basically. Okay. So here all these are speech data sets. So you have speech transcription, okay, between different dialects, 1,000 celebrity voices, okay, English Czech, English German, English Vietnamese, okay, etc. So these are all the speech data sets which are available to you. Okay, okay now when we come to deep learning, how is it we are able to do text, image, speech, everything, right? So there should be a method of converting that. Okay, so if we take something like natural language processing, okay, those words which you get, you should be able to convert it into a vector, okay, which can be fed into your deep learning method. So how do you convert it into a vector? So these are all some methods which are used for that. You have the TF-IDF, which is the term frequency inverse document frequency. You have bag of words, okay, which tells you the frequency of each word in the document basically. You have what is called one-hot encoding, okay, word-to-vec, glove. So all these are different methods of converting words into vectors, okay. When it comes to images, you're just feeding the pixel information. When it comes to speech, you're feeding the speech waveform, okay, into the network. Okay. So this embedding is a very important concept which is used here, okay, because without this, you wouldn't have been able to work on NLP at all. Okay, and you can see that we have such fantastic applications in NLP, etc., only because of these things. Okay. So this is a word embedding example. Okay, so here it could be, I mean, I'm not going into specific methods, okay, for word embedding, but assume that we have 4 words: dog, puppy, cat, houses. Okay, so some word embedding method is used and it's converted into vectors like this. Okay, so you have something like 7 values. Okay, you can see all of them are between 0 and 1, right? So you have a vector which represents a dog, another vector which represents a puppy, okay, etc. So there are methods of doing this. Okay, so what you do is in the document, you have to take all the words which are there, and you have to, they actually use a neural network to get these embeddings. Okay, so I'm not going into it. If you want, you can always look it up. Okay, and there are all these things like word2vec, etc., are easily available. Packages which you can use to convert it into an embedding, right? So if we take these embeddings, what has been done here is dimensionality reduction, right? Because we can't plot it unless it's two-dimensional. Okay, so it's converted to two-dimensional, and you can see here in this plot that puppy and dog are coming close to each other, right? And cat is coming little separate but closer to dog and puppy, and houses is coming far away. So this shows that it's a good representation of these words, right? So this way you can have a good representation. And when you have sentences, what they do is for individual words you find the word embedding, and for the blank also you'll have a word embedding, and you're going to concatenate all of them to find a word embedding to give into the system. Okay, so the word embedding is a very important aspect. Okay, most people don't realize that because there are packages available, they just use it, right? And then they just go ahead with that. All they do is just give the sentence, okay, and the system itself takes it, converts it into the embedding and gives it into the neural network. Then batch normalization, I'll not go much into this, but when you're giving values to different links, even in a neural network or deep learning, if suppose one varies between say 0 and 1 and the other one varies between 0 and 1000, right? So obviously the one which varies between 0 and 1000 will get a higher weightage, right? Or it will be given more importance. So what you do is you carry out normalization, and when you do normalization, you are converting all values between 0 and 1. Okay. So it's something like saying you take the minimum and maximum. The minimum will get a very low value and maximum will get you somewhere near 1. Okay, so you convert everything between 0 and 1 so that you get equal weightage for all the features. Okay, so this is one method. I will not go into it. You are using the mean and standard deviation to find the values over here. Okay. Okay, so this is the deep neural network we are talking about. Okay. What happens here is it makes this very difficult because of the large number of links that we have, right? Because from one layer to the next layer, all the nodes are connected to all the nodes in the next layer. Okay. And working on this is going to be difficult, but all of them may not be important. All the links may not be important. So what is done is that you come up with this concept. Okay, so this one is your input. Okay, so you have something like 3 dimensions here: the width, the height, and the depth. Okay, so you're using 3 dimensions there. So this is your input, which consists of 3 dimensions: red, green, and blue. Okay, so if you consider an image, okay, so you're using 3 dimensions and you're using something to reduce that. Okay, so you can see that the dimensions have come down as compared to this one. Here the dimensions have changed, etc. Okay, so you use what is called convolution and pooling basically in the CNN network. Okay. Okay, let us see this thing later. Okay. So what you're doing in convolution basically is that you're going to have a window like this, a filter, and you're going to place the filter on this. Okay. And you're going to multiply it. Okay. And once you multiply it, you're going to put that is what is called convolution basically. Okay. So you have this a 3 by 3 and that filter 1. So if you're going to do the dot product of this and this, you find you're going to get 3. Okay, and then you move this window by 1. If you move it by 1 this way, it's called that the stride is 1. Okay, if you move it by 2, it's called as stride is equal to 2, etc. Okay, so this is what is called the convolution, and once you do this, you are going to get network here. Okay, and if you are going to do for RGB, you'll get that into 3 times. Okay, so this is how you are going to get it. Okay, so this will be the convolution which you are getting. Okay, this 6 into 6 image is going to become 4 into 4 here. Sometimes you also add some zeros, padding like they call it, so that you can make it also 6 into 6 if you want, right? And if you say RGB, this will have, like if you have 2 filters, you are going to have a dimension of 2 this way. Okay, so that is convolution. Okay, so if you say RGB, you have 3 channels, so you are using 3 filters. Okay, and this is your values after convolution. Okay, this actually is the fully connected layer. So what do you do in a fully connected layer? You're going to flatten this. Okay, so you're going to put all these values this way. First you take the first row, put it like this, then you take the second row and you concatenate all of them and you get a fully connected layer. Okay. Okay, then you do what is called pooling. Okay, so what do you do in pooling? You take the maximum value. Okay, for example, if you take say a 2 by 2 image like this, you take the maximum value in that, right, and put that over here. Okay, so what happens is you will get a smaller image as compared to this. Okay, you can also do average pooling where you take the average of the values. Okay. So that is the thing. So if you take this, you are saying that you are taking 2 by 2 image here, and if you do max pooling, you will get 20 here, 30 here, 112 here, and 37 here. And if you take average pooling, these are the values you are going to get. Okay. So those are the 2 basic um, functions you're going to carry out. Okay, convolution and pooling. Okay, and once you do that, you're going to flatten it, and then you're going to have a fully connected layer right in the end, just like in the neural network, to get the class label finally. Okay. So this is how, suppose you have an image, you carry out convolution, max pooling, and you get a new image. Okay. Then again you carry out convolution, max pooling, you get a new image. Okay. Then finally, when you have done this enough, you are going to flatten it and you are going to have a fully connected feed-forward network. And at the end of that, you are going to get the class label, just like in a neural network, right? So that is how the CNN will work. So it is something like this, right? So this is your original image, and this is your filter, okay? And this gives you your next layer, okay? Then you're going to carry out pooling, okay? Then you get the next layer. You're again carrying out convolution, again carrying out pooling, and you get this, right? And then this is flattened, okay? And you get a flattened image like this, okay? Then you carry out the fully connected layer for with one or two hidden layers, and then you get the output from there. Okay. So what is this dropout? They randomly remove some of the nodes, okay, because there are too many nodes, right? So that is what they mean by dropout over there. So this is basically how the CNN looks. Okay. So what happens is that by the time you reach this layer, you find that you would have got higher level features, right? Here you are starting with lower level features, that is just the pixels, okay? And as you keep reducing it, okay, this one will have higher level features as you go down, okay? So because of that, since you're using higher level features, you're going to get good results, okay? So these are different types of CNN architectures depending on number of convolution layers, number of pooling, the type of pooling you do, type of convolution, etc. There are many different methods. Okay, so you can see in CNN only you have so many types of different methods. Okay, but the principle of CNN is how I explained it to you. Okay. Okay, next you have the RNN. So the RNN actually you have like stepwise, like, okay, so suppose you have, it was an awesome movie, okay, that is your input which you want to give into your RNN, and what do you want it to do? You want it to give it the part of speech, right? It should say it is what part of speech, okay, was is what part of speech, etc. So you first given this value and you have some input coming in here, right? And this U is your input weights, okay, and V is your output weights, and you're getting an output at every step, okay, and then you get a hidden output which goes into the next unit, okay, and again you give in the next input and you're going to get a hidden output of this and you're getting an output of each one, okay. So this is how the RNN works, and the nice thing about RNN is that it doesn't matter about the length, right? It doesn't have to be the same length, right? Every time it can be a different length. Okay, sometimes what they do is they um, also take information from the output here, I mean all of them together to get your final output, right? So here you have SI which depends on U, this is U, into your input, okay. W into Si minus 1. Si minus 1 is what is coming in from here, right? The first one doesn't have it, but the others have. And then you get Si. Si is your output here. And Y depends on V times Si. So V is the weights here, okay, times Si. So the hidden value here, okay, it depends on that. Okay, and depending on what you get, you can update the weights. Okay, so this is the RNN. Okay, so you get what is called deep RNN, where you get the output fed into another input, etc. Okay, we won't go into this. Just for the sake of showing you bidirectional. So you have this coming this way and this coming this way, and you have a function 3 which combines them, etc. So you can get some more complex RNNs. Okay, this is called pyramid, where you're combining these and reducing the complexity, reducing number of steps, and then going back, etc. Okay. So let us look at what are the applications in the RNN. Okay. So this is one to one. So you're giving one input and you're getting one output basically. Okay. And here what you're doing is you're giving one input and you're getting many outputs. So the input you're giving could be an image. Okay. So image is just given in the first time step, and the output you're going to get is a sequence of words, right, which will form the caption for your uh, image. This one actually has many inputs but only one output. Okay, so you're giving, say, a whole sentence, okay, and you're getting the sentiment of that. Does it have a positive sentiment or a negative sentiment, etc. Okay, and then you have many inputs and many outputs, many to many. Okay, like machine translation. So as many sentences as many words as you have in the input, you may have in the output also, right? So that is the thing. Okay, video classification, etc. Okay, so the problem with RNN is that it doesn't have it's a memory. So the old stuff is generally forgotten, right? And you have the vanishing gradient problem, which I told you for training, right? So when you're training, the value comes down to 0, the updation of the weights. Okay, so that is the thing. So you have what is called the LSTM, which is similar to the RNN. Input is the same, output is the same, but you have a cell here. Okay, and in this cell, things are done slightly differently so that it takes care of the vanishing gradient problem. Okay, so I'm not going to this basically. So basically what you have is you have these gates, input gate, output gate, and forget gate, okay, which helps in the directing the input towards the output in a particular way. And then you have what is called the gated recurrent unit, GRU like they call, which is another variant, okay, of the RNN, can be used instead of RNN. Again, it takes care of the vanishing gradient problem, and also it is much less complex, okay, as compared to the LSTM. So again, not going into this. Okay. Okay. So let us come to GANs. Okay, GANs is a very important concept. Okay, over here. So here we have, it's called generative adversarial network. So generative because you are generating images, okay, using it. Adversarial, it is trained in an adversarial setting. Okay, so it's called a adversarial network basically. Okay. Um, so what are you doing here? Okay, you are going to model P of X. So X is your image. Okay, so the P of X you are going to model so that you can use that to generate new images. Okay, so that's what is basically done over here, right? So here are some examples. Okay, so this is the input basically. Okay, and this is the generated image. Okay, so you can see that they are very close to each other. Okay, so this is just an example I am giving. So again here one of them is computer generated, the other one is a real image. Okay, but they seem to be very close to each other. Okay, so you find that GANs really work very, very well. Okay, you get very good results with GANs. You also can use things like saying that whatever output you get, you can say put grass, and you can get the grass, or you put you can add stuff into it. Okay, I'll tell you how to do that basically. Okay, add the sky, etc. Okay, we'll come to that, and let us look at the applications here. Okay, so you have so the applications you have is Um, yeah, generating examples for image dataset. In other words, your image dataset is very small, right? So what you can do basically is you can you can generate more images, okay, to you use for your work basically. Okay, generate photographs, generate realistic photographs, okay, generate cartoon characters, image to image translation. You have an image of one type, you can get an image of another type. Okay, so if you have the image during the day, you can get an image at night of the same thing. Okay, text to image translation. So if you say something like draw an orange bird with a black beak, etc., right, you should be able to generate that. The changing the view, etc. Okay, and other applications, converting photos to emojis, face aging. So you have a face at a particular age. Okay, so can you generate the face, say 20 years later, right? Or 20 years earlier, what the face would have been, etc. Photo blending, taking two photos and blending them together. Okay. Super resolution, you have a photo, okay, can you make a super resolution photo of the same thing? Photo in painting, so this would be useful when you have a photo which is got thank you, yeah, I'll keep it here. So something like old photographs, right? You have, or old paintings, you have some parts which have gone, etc. Right? So in painting, how do you paint that to blend with the rest of the photo, etc. It's so clothing translation, okay. So one type of clothing, can you convert it into another type of clothing, etc. So you talk about GANs, okay. So GANs, what you're doing is, I will not go into all these details. I don't think there's much time. Okay, basically we have a generator model and a discriminator model. Okay, so the generator model generates images, and the discriminator takes as input the generated images as well as real images. Okay, and gives as output either real or fake. Okay, so if it is a real image, it should give it as real. If it has come from the generator, it should come as fake, basically. So what you're doing is the two models are trained together, okay, in an adversarial fashion, okay. Uh, and the generator actually takes as input one input vector, right? And depending on the input vector, it's going to generate the example, okay? And you're updating that input vector, basically, okay? So what you're doing is that um, okay, so what you're doing basically is the generator, the discriminator is updated to get better discriminating real and fake samples in the next round, okay? And the generator is updated based on how well the generated samples fool the discriminator. So it is an adversarial thing. Okay, what is good for the discriminator is not good for the generator. If the discriminator is doing very well, then the generator is not doing well. Okay, so both of them are going to improve in this adversarial setting, basically. Okay. Okay, so what you have basically is you have a generator model, okay, random input vector, and you're generating examples, and you have real examples, and these are fed into the discriminator model, and it generates it, I mean, the output is real or fake, and depending on whether this is right or wrong, you update the discriminator model, and the same thing is used to update the generator model basically. Okay. So what you are using here is okay, so you are using adversarial training. So basically okay, so you are using this to update the loss which you are getting, or the difference between what you are getting here and the actual value. Okay, that you are using to update the discriminator and update the generator also. Okay, and your input here is Z. Like I said, it is a sort of a vector basically. Okay, and the vector is used to generate your image basically. Okay, so this is your algorithm which you have, right? You are updating the weights by using what is called the stochastic gradient. Okay, and these are some generated examples. Okay, and the rightmost column is the actual image. So this gives you the actual image, and these are the generated images. Okay, of the GAN. Same here. Okay, so these are generated images. This is the generated images of the CIFAR data set. So we saw the CIFAR data set earlier. Okay. This is the bedroom data set, again generated images. Okay. Um, so again bedroom images. Okay. Celebrities image data set. So that is used to generate new celebrity faces. Okay. And here we so you can see that there's a change in pose, right? So you can generate images with the new pose. Okay, you can change the pose. This is elevation, change the elevation. You can change the lighting. So you can see it's darker on the side, lighter on that side. And you can use wide on arrow, etc. So this shows how you can change the images the way you want it. Okay. And again chairs, you can see how they have got rotated and how the width changes over here, right? And here this is called style transfer. So you have the zebra and the horse here. So you're changing it. Okay, so you're changing horse to zebra, zebra to horse. Okay, so you're taking the stripes from the zebra and putting it on the horse, etc. Okay. So these are the different types of GANs that we have. Okay. Conditional GANs, I'll talk about them now. Lap GANs, etc. Okay, there are many types of GANs. So basic GAN is the same, but they just change it slightly. Okay, depending on the application they are using it for, basically. So when you say Wasserstein GAN, it means the metric which you use to find distance between points is changed to Wasserstein distance, etc. Okay, and here big GAN means progressive GAN. You're growing bigger and bigger GANs. Okay, so that you can get a higher resolution image, etc. So you can see that style GAN again is for image style transfer, etc. So what you find is the basic GAN is the same, but there are some variations on that. And what you do in conditional GANs, we have the class, you can also include the conditional value here. Okay, so you are including what is called, if you include the class label here, right, you can also include the class label here. So you find that when it generates images, if you are going to give this C value as input, it's going to generate images of a particular class. Okay, and this is not only class, you can use other different things there. Okay, whatever. For example, when you convert day to night, etc., you can give that as another conditional value into it, right? So that is conditional GAN. Let me not go into it because of lack of time, right? So that is the additional information which you are giving into the generator as well as to the discriminator. Okay. So this is the additional information, the green thing, okay, which is being given along with your Z, the latent variable here, and X, which is the input, right? Application of C-GANs, image generation with class labels, image to image translation. So if you have day images, you get night images, etc. A text to image synthesis, face aging, etc. So let me give you some. So this is conditioned on the class label, right? So you are generating zeros, ones, twos, etc. using CGAN. Okay, here you are converting the segmented thing into actual street scene. This is aerial to map, day to night, sketch to actual image, uh, black and white to color, okay, labels to facade, etc. So you can do image to image translation basically. Okay, let's not go into this. And this is text to image. So you're given something like this small bird has a pink breast and crown and black primaries and secondaries. So you give this as the conditional information, okay? And it makes use of that to generate images with those values in it, okay? So you find this is the output you're getting. The flower has petals that are bright pink, pinkish purple with white stigma, etc. Okay, so you can give in text also as your additional information. Okay, your main thing is an image, but you can give in text. Okay, as the additional information. So you can see how versatile it is, right? Okay, let us. So here you can change one type to another. Okay, you have a man with glasses, and you say remove the glasses. Okay, and you can get the man without glasses. And you can say change man into a woman, etc. Okay, so these are all different variations that you can have with that. This is called coupled GANs. We'll also just pass by these. So these are the various types of GANs that you have, and these are all the applications. Okay, change facial attributes, de-occlusion, okay, human pose identification, image blending, image translation, etc. Right? Object detection, text to image, etc. Okay, so the advantages of GANs we have seen basically. There's no need to go through this. Okay, we have seen how you can do so many things. Okay, using GANs. Okay, very compelling applications such as image super resolution, creating art. Okay, so for example, you can take one famous artist like say Van Gogh or some such thing. Give all his paintings right into the GAN and ask it to generate new paintings, okay, which uses the same type of style as he was using, etc. Okay, so the creative things you can do, right? Image to image translation, creating art, etc. Okay. Okay, then we come to transformers. So transformers. This is a transformer, you have an encoder and a decoder, and then you have the output with the softmax, the output you are getting, right? And what you can do is you can have a number of encoders, number of decoders, which are used there, okay? Now the important thing is here, the improvement on the transformers, right? So you find what is called ULM fit, Elmo, etc. Okay, you have something called OpenAI which worked on transformers. Okay, so Elmo is it uses some contextualized embeddings. Okay, so the way the embeddings are done is changed there, right? And OLM fit universal language model fine tuning. So what happens there? You are using a language model. In other words, you are using some data, okay, language, say English, some word net or something, and you are pre-training the this thing, the transformer using that. Okay, so that pre-training actually goes on there. And if you look at BERT is something which is very well known for that, right? It is pre-trained. Okay, so it will be pre-trained on some things like WordNet, etc., or Wikipedia, etc. So once it is pre-trained, you use that pre-trained model. Okay. So what you do is that you're pre-training it, and then when you want to use it for a particular task, okay, you're giving the input to BERT, and you're using a classifier. Okay. And you're doing a little bit of training. Okay, once you use that classifier, you don't have to do much training, and you're getting a good result from that. Okay, so this is the pre-trained BERT. Okay, so you find that this is really working well. Okay, so you have two types of BERT basically. Okay, let me see. Yeah, so you have the encoder, lesser number of encoders, more number of encoders, right? So basically it's only the encoder. Okay, so the decoder part is the classifier which you are going to use. Okay, so you have 12 in the base version, 12 encoders, and you have 24 encoders in the BERT large, basically. Okay, so this BERT is something which is making ripples, basically. Okay, it's doing very well, giving very good results. Okay, so I'll not go into this basically. Okay, so uh, I just sort of gave you, let me just give you overview of what I told you all this time, right? How I told you how deep learning methods are very good for AI for a number of reasons. One is the good result it gives. Second is because it can be used for different modes, okay, for images, text, speech, etc. And it doesn't need feature engineering to be done, right? So these are all important points to be taken here, okay. And we saw different deep learning methods. For example, CNN, we saw RNN, um, we saw GANs, and we saw transformers basically. Okay, so this is a sort of very fast overview of all these things, right? And what we saw was that you get very good results as compared to other machine learning algorithms with less work from the human side. Okay, everything is done by the machine basically. Okay, um, and you have many levels with the higher levels being developed from the lower level features. Okay, and transformers has led to pre-trained models like BERT, okay, which is a very important advancement when it comes to transformers. Okay, um, and you have a whole number of applications which are sort of quite wonderful, right? The thing, that's why they talk about the wonder of GANs, etc., right? Because you're getting such beautiful results out of whatever has been done, right? You won't know whether what you have got is fake or not fake, right? It's like that. And you have number of applications, and especially in the medical field it's very useful, right? So if you take, say, ultrasound images, MRI images, histopathological images, etc., how do you get information from that? Okay, is it cancerous or not cancerous? What is the problem? Okay, etc. That there's a whole lot of work being done in this. So this is a very important um, advancement when it comes to learning, basically. So once deep learning has come, everybody uses only deep learning. They don't go into machine learning algorithms anymore, right? So it's giving such beautiful results. And I can say what has aided this is the increase in computational resources which we have at this time. Also the increase in the data sets that we can get. Okay, and I think an important feature in industry from now on would be the creation of data which is authentic, right? Because all these things require data. They don't require you to work on the algorithm as such or develop features or anything like that. Okay, so but the data has to be good. The quality of the data is important. Okay, so that is one very important future aspect in when it comes to AI, I think. So I'll stop here. Are there any questions? Yeah. Mm. Yeah.
Check.
Mm.
Text this thing recognition everything, so this we can use in machine learning also, machine learning
Yeah,
algorithms.
yeah, you can use machine learning
Any
algorithms.
machine learning algorithms that we
Yes.
can use, ma'am?
No, you can use embeddings nowadays, no?
Okay.
So you may not be able to do everything like summarization and all. You may not be able to do using machine learning algorithms, but some things you can do. For example, you can change words into their embeddings and give it even into a machine learning algorithm.
Okay.
Okay, so you can use that embedding and do classification, right?
Okay.
That's also possible.
Okay.
In fact, that was done before even deep learning started. Okay, they were, but not to such an extent. Okay, so you can use machine, and many people compare machine learning algorithms with deep learning algorithms and show which one is better, if it's possible to use machine learning algorithms for some of them.
In machine learning, ma'am, we can do if you use classification, we can use sentimental analysis, everything.
Yeah,
And here also we can
yeah, yeah.
using deep learning.
Hmm.
So you suggest us to do like example, if you wanted to do sentimental analysis, you suggest us to do in deep learning or machine learning?
So what I feel is that if the application is small, okay, if you don't have too much data or you're not going to use so much data, etc., it's machine learning may be enough for what you're doing, okay. But in all cases, it may not be enough. Okay, suppose you are using it on large scale and you have large amount of data, etc. You can use deep learning methods for doing it.
Okay, ma'am. Ma'am, if consider we have linear regression, logistic regression,
Mm.
all those things, like we can't do it with deep learning. This thing, maybe if we use
No,
CNN.
the only way you can use is if you can convert it into numerical values, right?
Oh, yeah.
So if there's any place where you can convert it into numerical values, you can use those methods also.
Oh, can we use
Okay.
like that, ma'am? I mean, converting into like what is the procedure if you wanted to convert into numerical values?
So if you want to convert into numerical values, see for images it's difficult, right?
Hmm.
Images you may have to segment it and take out the features, etc.
Okay.
Okay, but for text, if you can use embeddings, okay, you can use those embeddings as numerical values.
And we can do all this linear
Yes, you
regression.
can
Okay.
do.
But it's simple to do with only linear regression.
Yeah, I mean, it's easier for human beings
it's
just to put it into a deep learning method and get an output.
Okay, ma'am.
So
There's
that's
only
the basic
this
idea.
four in the deep learning.
Hmm?
Only this four: CNN, RNN, and again GAN and
No, there
transform.
are others also. Oh,
Okay.
there are others. Okay, and you also nowadays have what are called diffusion models,
Okay.
etc. There are other, you have many variations of these.
Okay.
These are some standard methods.
Okay.
Okay, like I said, you have LSTM and GRU, which is variations of RNN. Okay, you have other like autoencoders, Boltzmann machines. A lot of different variations are there in the architectures. You can get other architectures also, not only these.
Thank you. Thank you. That's all.
Hello, ma'am.
Yeah.
I would like to ask about word embedding. While doing word embedding, we are supposed to fit a vector in a high-dimensional space, right? While doing, while fitting the word in a
So
high-dimensional space.
usually they use a sort of neural network for doing it. No, for example, if you have a document and you have all the words in the document, no,
Yeah.
you are going to use all those words so that you get separate individual embeddings for each one. Okay.
Yeah.
And there are, like I said, many methods of doing it. Okay, and it's possible to do it by looking at the context, the previous word, next word, all these type of things they see, and they see that words which are close together in meaning will have, embeddings which are close to each other.
Okay.
Okay, there are methods. You need to go through those.
Yeah.
All those
Those are for only English, or can we use for different languages like Hindi, Kannada, Tamil?
Yeah, nowadays they are trying to do those also.
Okay. Thank you, ma'am.
Lot of hype which is about DeepSeek. So how DeepSeek is different from the GPT models basically?
I don't know what are the differences, but it's another method of doing the same thing. Okay. So basically, they take information from internet, etc., and they make use of those to answer whatever you want, etc. Right? Just like ChatGPT.
So
It's
it's a,
another variation. It's a question of which one is better. That's all.
so it's
It's brought up by different companies, right? One will be Google, means something else will be by some other, like that. That's all.
thank you, sir.
Any other questions? Thank you so much, ma'am, for sharing your expertise in the field of AI, especially in neural network. I'm sure all seated here would have got an overview of different types of neural networks, CNN, RNN, the problems that are there in the image, the speech, and the task in NLP. And also we have got an overview of different data sets that are available that we can work on. I thank you for sharing your expertise on it. As a token of our gratitude, I request Dr. Mary Jacob, coordinator of ATAL FDP, to offer a memento and a certificate to Dr. Sushila Devi.
Thank you.
Once again, thank you, ma'am, for this enlightening session on advancements in artificial intelligence. It was really an enlightening session. Thank you.
Thank you.
Yeah, we'll gather here for a group photo. Everyone. It is a pleasure to welcome you all to the session 2 of day 3 of the ATAL Basic Faculty Development Program on Mastering the Frontier of Artificial Intelligence, Trends, Challenges and Applications. It is an honor to introduce our esteemed speaker for the second session, Dr. Bindu Krishnan. Dr. Bindu Krishnan is a senior data analyst at IBM Kochi with over 20 years of experience in academia and research. Ma'am holds a PhD in statistics and an MTech in data science and AI, specializing in distribution theory, time series modeling, data analytics, and machine learning. She has published extensively, including the book Probability Distributions, Random Process, and Numerical Methods, and multiple research papers. Skilled in R, Python, Tableau, SAS, and SPS, she has led leadership roles at Jain University, St. Kitts College, and St. Teresa's College. Her certifications include AWS Machine Learning, Data Science Math Skills, and Executive Data Science Capstone. We welcome you, ma'am. I now request Dr. Mary Jacob, Coordinator, ATAL FDP, to welcome our speaker with a sapling. Thank you, ma'am. Now I request Dr. Bindu Krishnan to take over the session.
ഇത് ചേഞ്ച് ചെയ്യണ്ടേ അപ്പോൾ അല്ലെങ്കിൽ പിന്നെ അത് അവിടെ വെച്ചിട്ട് ചെയ്യണോ ഇറ്റ് ഓക്കെ ആ അല്ല അത് പറ്റുന്നില്ല പോട്ടില്ല ഇത് മാക്കല്ലേ ഇറ്റ്സ് ഓക്കെ ഞാൻ ഇൻ ബിറ്റ്വീൻ വേണമെങ്കിൽ പറഞ്ഞോളാം Okay. Good afternoon. I am so glad that even more students are here than teachers, even though it's a faculty development program. So just I feel like standing in a classroom. I'm happy with that. I'm so much passionate of that. So please think that I'm a person from IBM, I'm a big... No. Actually, I was in academics for several years. So just treat me as a teacher like your faculty here. Okay. So anyway, first of all, let me thank my sincere thanks to the team, Gobika ma'am, Mary ma'am, and all other organizers from this Kristu Jayanti organizers, management, principal, faculty, everyone, for this invitation. Just before 1 hour, actually before half an hour, we were telling about last 3 years I was planning to come here, but now it happened. In between, actually during the COVID time, actually we planned from FDP. That time, just on the previous day of this that program, I was affected 3rd time COVID, so I was not able to come here. But after that, I have delivered some online sessions, but this is the first time I got an opportunity to stand here. Anyway, thanks, ma'am. Okay, so since it's a combination, just I would like to know how many faculty are here other than this Gobika ma'am. I think majority from student research, so I can focus more on that side with your permission. Okay. Of course, even while during the lunchtime, actually I was confused from where to start, because based on the title, actually I thought of starting from Gen AI. But if I'll start from there, maybe since some students are there. See, I usually deliver sessions only. I won't stick. I never stick to cover maximum topic. No. Some basic things, even though you are going to hear some basic things from here, but I am sure that you will get something, even you are aware of all those things. I think it's better to, I think all of you are aware of machine learning, right? Okay, I'm not going to take machine learning. But if you are aware of machine learning, say, let me take regression topic. Are you all aware of regression topic? Regression, fitting a regression model. Okay, suppose I have given you a data set. By hearing regression, you thought you had decided to leave from here. No. Anyway, if you have some other work, please carry on, no issue. Okay. So I think only PG students, right? PG and research scholars. Okay. So 100% sure you have fitted at least, or you have developed at least one regression model using some data set, right? Is there anyone who is not aware of fitting regression model or developing regression model? I'm not asking you to fit, just I am asking you whether you have some basic idea of that. So if I'll provide you a data set, the first thing which you do is you will divide that data into training and test. Then, if sklearn is there, no issue. with single line. Is my mobile? Yeah, no, I don't need. No issue. So if that module sklearn is there, with a single line code, it is possible to develop that machine learning, that regression or whatever be the machine learning model, then fit with your data. Then after that, you all have developed regression model, right? Fit with your data set. I am not asking to a single person. I just want to know up to what or up to which step you are familiar. Okay, I will tell. So start with the data set, split that data set into training and set, import the corresponding packages, especially a sklearn. Or if you want some data visualization techniques like pair plot or scatter diagram or something like that, you can import matplotlib, seaborn, etc., etc. Okay, then after that, find the mean square error, find the R-square value. Okay, take the test data set, check with this. If it's 90%, no other thing. Okay, my model is good. It's very easy to predict the future. Bas. In addition to that, I'm asking you what all things you learn from regression. I'm not going to explain the things which I shared now up to developing model, R-square value, then finding mean square error. Anyway, cross-validation also. Okay, some of you might have done maybe cross-validation also. My question is, suppose you obtained 98% accuracy in your test data. Okay? Are you confident to say that, yeah, my model is very good for future prediction? Definitely you say yes. But no. Okay, take the case of mean square value, mean square error, which is one of the performance measure in regression. Suppose you are getting the mean square error as say 5 or near to 0, not 5, near to 0. Okay, mean square error as 0, some value near to 0, and R square value as R-square value. Are you aware of this R-square value? Yes or no? Please tell me so that otherwise I can explain that. Yes. Others? No, okay, then I'll come to that. Yeah, only thing is that it is equivalent to accuracy. Right? I'll show you or I'll tell you actually how much the dependent variable, variations in dependent variable is explained by independent variable. So the degree of the R-square value is the degree to which the variations in dependent variable could be explained by or can be explained by the variation in independent. How much it is affected, that's all. How much the dependent variable is affected by the independent variable. You will get a value lies between 0 and 1. Or it's equivalent to accuracy, that's all. Simply saying. Okay, so definitely if you will get that accuracy or if you have that mean square value, of course you can update the parameter. All those things are there. Using the gradient descent, all those things are there. But I am not saying that, especially statistically speaking, I am not saying that you cannot conclude that my model is good with 98 or 99% accuracy. Reason is that there are some basic assumptions for regression analysis. Anybody aware of that? Basic assumptions in regression. First is linearity, which is understood. Linear regression, because we are dealing with the linear regression. Now, second thing is errors are normally distributed. Have you heard about that? Even though that is one of the important conditions in developing regression model, I am 100% sure that even 5% people will check it or not, especially from the machine learning perspective. I never blame computer science persons or machine learning people. No. Because I am a person standing in both statistics and computer science. But these are some basic things usually while we skip, especially while dealing with the complex data sets. Okay? That is the difference between dealing data in academics and industry. Myself also, while in academics, I was doing it like that. Simply fitting, developing the model, final accuracy, stop. Then one other example I can say, case of dealing outliers. What we do? Whatever be the models which you are going to predict, either machine learning or some other. If you have outliers, have you heard about outliers? Outliers. All are aware of that. Okay. In machine learning, if you have some outlier in your data set, what will you do? You will ignore that. Right? But in industry, that is not the case. Sometimes that itself will be the most interesting part. We will deal with, we won't ignore that. We never ignore that. That itself, we will take it as research. How do we research that? I can't say in one or two sentences. Different ways are there. Okay, then handling missing value. What we do? If you have only one or two missing values, you will delete that corresponding row. That is the first method, right? Ignoring corresponding rows. Or don't ignore the variables, because variables, of course, related to the affect your data set. Okay, so the simplest way is delete the corresponding row. Otherwise, you can do the imputation. Find the average of corresponding. Right? How can you guarantee that that value is a good thing? Good value for that corresponding position. Yeah, so these are the differences between. I'm not saying that these things we can do only in industry. No, in academics also we can deal with different. Lot of articles are there. See, in industry, don't think that we are actually, of course, we are contributing something from our own. That is there. But again, especially those who are working just like me, especially data related positions, in industry also we are actually referring articles. Based on that reference, actually we will try to come up with our own algorithms or our own contribution, something like that. Please don't think that this reviewing article is only for academics. No. But lot of differences are there. I'll come to that especially. I can say actually the largest skill gap is related to the theory of AI or theory of data science itself. Say for example, the related position. Take my role itself. Because data scientist is actually, that position comes top related to this AI or machine learning, or either machine learning scientist or AI engineers, data analyst, data scientist, whoever be that position. Okay. So in corporates, this data scientist actually cannot focus on simply building the most accurate models or simply making predictions. No. They must consider the impact on the business also. That is the main difference between this academia industry. Okay, so that is one thing. Now, they should not be afraid of taking iterative version. I mean by pushing one at a time, rather than waiting until all the research is done before presenting the findings. That procedure actually we are doing in academics, no? Because we are supposed to do. While getting that final model or whatever be the final interpretation, that time only it's not the case. Then another thing is distinction between this industry research and academia research is that ground data. So although I believe this is changing, but the current scenario is that industry data sets tend to have more hiccups or outliers or bugs. So we will first try to rectify those bugs. Then only we will move to research. But here what we do is that we will try to ignore that. So that is the difference. Maybe to overcome those bugs, maybe we will take months and months or days, for more than 1 month. That is not a matter of fact. But of course, at the same time, speed is needed. Okay, so similar to that, lot of things are there. There actually at work, a pragmatic approach is needed so as to measure this complexity, trade-off between the complexity and impact. Then secondly, or thirdly, I don't know, 2-3 points I mentioned. Business is faster paced, less structured, and more hands-on than the academia. Okay, so usually while developing or building models, these people, this industry people, here actually I am specifying only the case of those positions related to this data scientist or machine learning scientist or AI engineers, machine learning engineers or data analyst, whoever be that. Okay, so now move to, so why I started with data. See, I strongly believing that there is no AI without data. I don't know how many of you agree. Maybe some industry people will argue with that. Say for example, I strictly focus on this. Full data, then AI. Then of course machine learning, then deep learning, etc., etc. But some people, especially industry people, I don't know about the academics. I don't know means, I don't know whether the academics people will argue or not, because I also was in academics, so because that may be that might be one of the reason I strictly followed this concept. But some people will say only like this. Why? Yeah, maybe some options are there, some possibilities are there to come up with some AI tools without data. But obviously we can say something without machine learning. We can define or we can come up with some AI tools without machine learning. Even when I joined in IBM, even though I was hired for, actually I joined only 3 years back. I was in academics for 22 years. But anyway, during that, then you can ask me why you choose that one. Simply a change. Especially my passion towards this second thing. I can say I was, once upon a time, I was very much addicted to that second term, machine learning. The reason is there, even because of that reason, actually, I have done that, you heard no while during the introduction, MTech in data science. Actually, my first post-graduation is MSc in statistics. After my PhD only, I have done MTech in data science. It's only because of my passion towards this machine learning. The thing is that, no, sometimes actually I wonder in many articles, take the case of this regression itself. Actually, for this particular term regression, it has got this much hype only for last few years. Maximum of 15 years. Agree? I don't know. CST people will agree or not. 15 to 20. Okay. 20 years. This much hype. But please note that regression, it's an old method. Century back method. 100 years old method. Thing is that statisticians have the limitation of this computing power. I strongly agree with that. Even why I took an MTech, that may be one of the reason. Definitely, I have that limitation of computing power. How to handle all those things. Some basics I know. So that is why actually I decided to do that. But here actually, I don't want to share my personal things. But what I want to share here is that there is no machine learning or AI without computer science. There is no machine learning or AI without statistics. It's purely a combination. Because theoretical concepts actually comes from statistics as well as, mostly statistics as well as mathematics. But computing power, especially that role of computer science actually while storing or that complexity, once an algorithm is learned, it's we check whether it's efficient or not storing. So a lot of things are there. Single word, computing power. Then I am not saying that you need to take a computer science degree for to perform well in this area. No. I myself proved that. That is why I am saying you confidently. But some basic things are there. You need to know both in this mathematics as well as mathematics and statistics and computer science. Okay, leave that. So that is why I would like to say, actually from my side also started with the data science. Later on, I decided only to stick on like this. From without data, nothing. But of course, we can define some AI tools like I mentioned. When I joined in IBM, actually I was assigned to a project, DB2. Have you heard about DB2? It's actually a database tool. People are saying it's a AI tool. I don't know. IBM people also saying it's a AI tool. But it's purely different from machine learning. No connection with many. DB2 actually it is a database tool. Store data set, etc. etc. Okay. So it's not a machine learning, but it comes under AI. Because some previously I couldn't say, but nowadays actually some AI implementations are happening there. So we can treat it as a AI tool. Okay, so a lot of things are there which doesn't come under machine learning, but in AI. But everything relates to that data. So that is why I started even my first slide actually with data science. Simply transforming information into knowledge, that itself. Right? Or it is the science of using data to build models that lead to better decisions. Of course, which in turn add values to individuals or companies, organizations, institutions, etc., etc., etc. But anyway, the field of data science includes the art of artificial intelligence, machine learning, deep learning, everything. Right? Okay, now come to AI. Because maybe the theme is, see, even though the theme is like this, actually, in that title itself, I am not saying that we can start from the first word, AI horizons. Instead, actually, we will start from this term. Do you agree with me? Without doing data analysis, even graphs, exploring graph, it's part of data analysis, right? Then, after that only we will move to some inference. What is inference? Making some decisions, right? Based on some sample, etc., etc. Okay? Theoretically saying statistical inference, even machine learning also we call it as statistical inference. Generally, inference means, of course, decision making, but in machine learning also actually we focus on actually statistical inference because that deals with making inference for samples based on population. Now you can ask me, we are dealing with big data or large size data. How can you take it as a sample? It is a sample, whatever be the size of data. Even I mentioned in industry usually we deal with complex data sets. But we cannot say that it's as a population. We will reach some inference by making analysis of this sample. Population means actually, or sample is part of population only. So based on that analysis or based on the inference, of course, discovery also that final conclusion there itself. Even these words are actually connected with not only to this data science, even I couldn't skip that term, data analytics. Now I am asking you, what is the difference between data science and data analytics? Analytics also we say making use of data for better decision making. But data science actually it's an umbrella term, where data analytics comes under that. Then what is the role of data analysis? Actually, there are differences between these terms. Data science is actually an umbrella term, or it is an interdisciplinary or multidisciplinary field that includes algorithms, systems, tools, techniques, etc., everything to extract knowledge or insights from either structured or unstructured data. Simply saying difference between data analytics and data science means just the difference between computer science and computer applications. Data science equivalent to computer science, data analytics equivalent to computer applications. Now, so why I mentioned that word data analytics? Discovery, data analysis. Again, next term. What is the connection between this data analysis and data analytics? Is that same? Is that same? No. Data analysis, actually, it's only a sub-component of data analytics. See, if I'll provide you a data set, if I'll ask you to do some analysis, not machine learning project, even though if you take it as a machine learning project, then also it's fine. But see, if somebody asks you to do, I'm asking you, okay, do some data analysis with this. What you do? First you will do some data pre-processing things. Then, what all things you know? Okay? Then if you want, you can take it as some exploratory data analysis or something like that. You can start with basic things. I know you people are from computer science background, but I'm asking you, is there anyone who have not studied how to find the mean, median, mode, etc.? No. Have you studied histogram, the types of visualization techniques? Starts with histogram, bar chart, pie chart, etc., etc., right? These are all part of data analysis. Then definitely these are part of data analytics. And I said data science is the umbrella term. So definitely the role of this analysis plays a role there also. Now my question is, what is the difference between data analysis? This, while doing all these things, whatever techniques you know, whatever methods you are familiar, either mean, median, etc., then some charts such as histograms, etc., etc., then what all things you know other than this? Testing of hypothesis, are you familiar with testing of hypothesis, statistical test of hypothesis? Some t-test, okay, some test. So that's also part of analysis. Then come to the regression. You can do regression with your data set, prediction. Okay? So maximum you will do only up to that. Do you agree with me? Or if you know some other techniques, tell me at least that word. I am not asking you to do that. Visualization already I mentioned. Various visualization techniques. Okay? So that's begin with histogram, but lot of things are there, of course. Any other techniques? Any other techniques? Feature engineering, again, it's part of data pre-processing. Initial stage. Selecting the feature selection, feature extraction, all those things, right? Any other things? Okay. So, if we stick on to that regression, if we reached up to that regression, of course, we will come up with sub-predictions. Okay? So, if you finish only up to that, or if you are done only up to that, we cannot say that it's a data analytics. Because for data analytics, we need at least 4 things, 4 stages of data analytics there. First one, that is, you have done something, no? You started with your data set by finding mean, median also, etc., some visualization techniques, etc., etc. Okay, so that part actually we call it as descriptive analytics. What happened? Simply gives what happened to your data set. Okay, now the next question is, why it happened? Why am I getting, or why are we getting the value like this? Why this is why an outlier like this, or why this missing value is there? You have to diagnose why it happened. So that is the second stage of analytics. We call it as diagnostic analytics. In many cases, most of the people will skip that part. Okay, I got these things, these results. Okay, move to next one. Move to next technique. Am I right? Okay, anyway, no issue. So, if you are trying to find how we are getting this value, how I am getting this value, why my graph is look like this, etc., etc. So, if you try to diagnose the reasons for that, you can say that you have done the part of diagnostic analytics also, second stage. Third stage is predictive analytics, which you have, if you have done the regression, fine. You have done some predictions, some forecasting for the future. One more stage there, prescriptive analytics. That is, whatever be your predictions, So it is mandatory to do this stage, especially in industry. Prescriptive analytics means we have to recommend some action based on the prediction, based on the forecast. Okay? Usually that part, I'm not saying that skip, that is not required, especially in academics. That is the reason. We don't want to implement that. But it is possible to implement that. See, for example, after coming up with some predictions, if you try to, you people are from computer science background, right? So you can try making an app or something like that. So recommend some action based on forecast. Okay, so until you finish all these things, then only you can say that, or you could say that you have covered all the stages of this data analytics. But if you focus on data science, some more things are there. Now moving to AI. So as I mentioned, of course, AI is quickly being utilized in business as well as societal functions, creating unprecedented opportunities across sectors and transforms our lives. Especially machine learning scientists or AI engineers. Actually, these two roles purely focused on that. Even data scientist role also actually closely related to that. Anyway, these people, these professionals, actually they are making all kinds of decisions based on this. How to learn, how to write, how to move, how to consume and interact with each other. So of course, a quick look on this technology landscape shows the power of AI in everyday life. From, I can say, voice assistant, that power smart speakers, from voice assistant to, say, high-tech coffee makers, I can say. Right? These technologies are actually becoming the mainstays of life. So this evolution actually has led to a positive change in either AI or I can say machine learning job markets. Okay, no doubt in that, all of you know that. Okay, so don't worry, since that AI term is there, why are I this simply skipping that and focusing on data science, data analysis? No, see, there is no AI without data, no doubt in that. So that is why I strongly believe in this. Not believe, follow this. But some industrial perspectives, while dealing with some industrial perspectives, we need to follow this one. But there also some connection there, right? Look at this part. Combination is there. Without that, it is impossible. Okay, whatever be that, according to your convenience, you can choose those graphs. Whether that data science, artificial intelligence comes under AI. I think AI, simply definition, or what is that everyone knows? Artificial intelligence. Of course, it's a wide-ranging field of study, I can say, which is concerned with simply building smart machines capable of performing tasks. Is that enough? That typically requires human intelligence. That is very important. Don't skip that. Okay, anyway, yeah, predictive analytics already I mentioned. But the role of this predictive analytics in artificial intelligence is unpredictable, I can say. Because lot of techniques are there. Even especially while coming up with new tools, AI tools, there also we are actually using different predictive analytics. Say for example, suppose you want to develop a machine to predict, come up with some example. To predict? Teacher, you say predict? Gas leakage. Okay. Can I take hourly basis or some timely basis? Okay. Gas leakage. So if you are planning to come up with some or planning to develop a tool for this. Okay, a tool, agree with that. Definitely you will start with some, if you are planning to approach the machine learning techniques for that, definitely you will start with from data set, right? So data set, even though you plan to apply only machine learning techniques, of course machine learning techniques comes under this predictive analytics. I am asking you, if you want to predict that on hourly basis, some timely basis, hourly or by second or something like that, definitely you need to start with a time-based data. If you start with the time-based data, you cannot skip at least some basic time series analysis on that, which is again a predictive analytics technique. Okay? So, in one word, I can say we couldn't skip this word while dealing with either AI or machine learning or data science, whatever be the word which you are using, deep learning or anything. Okay? So, predictive analytics can be built using a variety of techniques other than machine learning techniques. Machine learning techniques, it's understood. It's for predictions. But other than machine learning techniques, actually, especially for AI, time series analysis, then especially if you are dealing with some, whether a patient, suppose you want to come up with a machine to predict whether a patient will survive or not after 5 years or after 10 years or after 20 years, it's left you. After 5 years, see, she is laughing at me. After 5 years? No, I am not talking about you. 5 years, 10 years, 20 years, 25 years. For me, maximum, that's enough. I am 49 now. Okay, 20, that's enough. Okay, anyway, suppose you want to predict something, right? So, there actually, in addition to this machine learning technique, other than this, apart from this machine learning techniques, we can use one other, actually it's a statistical technique, but somewhere machine learning also we are using that. Survival analysis, have you heard about that? Survival analysis. Survival. Okay. So anyway, survival, Kaplan-Meier estimate. One name is there. Kaplan is one person, Meier is one person. Not M-A-Y-O-R, M-E-I-E-R. Leave it. Anyway, there is an area, there is a field of statistics. It's a branch of statistics, survival analysis. Especially this medical data, all those things, actually we are doing this. But this survival analysis is closely connected to AI also. I can share one example. Actually, this, okay, while moving to case studies, I will explain. Okay, then predictive analytics. Yeah, this already I mentioned, few points. Difference between, even though I mentioned time spent by data scientists, don't stick on to data scientists, whatever be the roles, positions related to AI or data, machine learning scientists or machine learning engineers or AI engineers, data engineers, whoever be that person. Okay, so 2-3 points already I mentioned. Then especially sticking to, look at the goal. In academia, purely we try to improve human knowledge. But in industry, it's not, be frank. It's not like that, making money. That's all. Okay, then success criteria. Usually focus on publishing papers, right? We have to come up with some contributions, then ultimately publish papers. But in industry, it is not like that. Create and deliver. Who needs paper? Even from my side itself, be frank. For the last 2.5 years, no, I have not published any paper, any research paper. Because no, but of course, contribution actually, in industry, the contributions will be measured by patents, publishing patents. That is there. I think with my experience, even that much content is not required. Whatever thing which we are predicting, which we are contributing, simply, only thing is that we need to defend it. Especially usually for last 2 years, actually I submit patents to, we have a platform in IBM itself to submit patents. The thing is that defending, at least 4 to 5 stages are there. Just like defending in the final, that open defense. Just bullets are coming, just like stand like this, so many bullets are coming. But once we get that, no, it is, we can even avoid this type of plagiarism, all those things. Otherwise, no, while writing research papers, how much we need to check for plagiarism, all those things. Reverse, especially in the introduction part. Right? We can avoid all those things if you proceed. But definitely those who are doing research, I am not degrading that. Wherever research papers are required, you have to focus that. But patents nowadays in academia also, you can see so many people are coming up with publishing patents. Not through bribing. Okay, anyway. Now next thing is finding a better way to approach. In academics, finding a better way to do a new thing. But in industry, not focus on that much, simply fastest to finish as much as possible. Okay. Then last one, importance of speed, not the most important. I think some people will fire me by looking at that. Not most important in the sense, usually in academics research, how many years it will take? How many years it will take? Minimum 3 years, right? Minimum 3 years. Okay. But if we request something like that in industry, okay, our boss will say, okay, you go and you take 3 or 4 years at home. Just before beginning this session, actually, I was sharing to ma'am and Mary ma'am. Actually, even though my stand also I can share. I am actually working as a senior position. But for me also, I'll be assigned some task with 2 weeks. That 2 weeks may be different in different organization, but some agile things are there. Have you heard about the word agile? So in agile, actually, it's saying 2 weeks. So maximum of 3 weeks. Okay. In IBM, actually, we have to. So in we will be assigned some task to finish in 2 weeks. Sometimes we will be able to finish it in 2 weeks, maybe before 2 weeks. But sometimes we have to overtime. Okay, we have to work overtime, definitely. So, what I want to share is that we will not get 2 years, whatever be the lengthy assignment. We won't get 2 years, 3 years to finish. In a relaxed mode, we are doing here, no? Maybe it depends on your project. Maybe, I don't know, anyone who worked in industry sitting here or not. Purely depends on your project, I can say. Some project maybe it's very tight, but some project itself, sometimes, especially during the release, all those things. Release in the sense, industry is actually mostly product oriented. Say for example, in my product actually last release was during September. So during release time, we all sitting everything there in the office itself. That happens for all products, not only our products. So that time, oh, yesterday I left here by 12 o'clock, today morning again, I can't come. No. If you are not willing to come, okay, you go and sit at home permanently. That difference is there. But here actually what you do, in research, especially in research, first 6 months coursework, studying only those things, those papers, only 4 papers. Same situation if you face in industry, no, definitely you will be asked to come up with at least 1 or 2 papers during that coursework time itself. 1 or 2 papers, not submission, publication. Of course, quality is very much important. I think no explanation is needed regarding that. Everywhere, either as well as academics as well as industry. Okay, anyway. Technical skills, please don't think that those who are doing in the corresponding area, say here I am taking the case, only the case of data scientist or data related positions, machine learning scientists. Please don't think that those who are aware of mathematics, statistics or computer science, programming, etc. are able to perform well. No. Some additional things are there. specifically I can say some critical thinking. See, if I'll give you a data set, usually this data handling positions, I'm mentioning only data handling positions. Your boss, suppose you have joined in some company, seniors or juniors. So your boss will give you a data set. Most of the cases, no objective will be there. It's your duty to frame the objective. But you will be asked to do some task, okay, with this. How can I get, say, more than 100 million profit? Not sales. How can I get more than 100 million profit from this product for the next year? Come up with a machine learning prediction for that. Only you will be given a question like this. So you have to set your objective. Whether thinking is required or critical, whatever be that word, thinking is required or not, my question. Yeah. This first thing actually, it's very, very, very much important for the data related, for those who are dealing with data. Then structured approach, of course, some creativity, some etc., etc. Problem solving skills, that is also very important. See, by looking at this, don't take it as a specialist student, don't take it as, oh, I don't want to go industry, I'll sit somewhere here. No. So actually this is, especially I can say, I think you all are on LinkedIn, right? Recently, I forgot his name, one Amazon interview questions posted one person, I forgot that name. A lot of individuals are there posting like that. One Amazon, myself, I was wondering, oh, what is the requirement of these things for a machine learning scientist position? That type of questions. He lost it. I think he failed for some case, 2-3 cases actually asked. Even myself also thinking, what is the role of data here? What is the role of machine learning here? What is the role of... Actually, that interviewer is checking these things with that candidate. But don't worry about that. Just keep these things in mind. If you are 100% skilled in the corresponding technical areas, then also it is not necessary that you will be able to get a good position. Some reading is also required, that's all. Some reading, some practice, especially those who want to catch some job opportunities in this data related area. Technical sides you can improve simply by, not by learning. Especially programming, copy paste never work. Of course, after hiring, you can use ChatGPT or something like that. That is okay. Especially coding test you can expect. Even I usually take interviews for especially positions related to data scientists. Usually in IBM actually since some students are there, that's why I am sharing these type of things, okay? Is it okay? Okay. So that is why I'm sorry, because for so many student faces I am coming, even though research scholars. After research you are also, that's why during the beginning I asked how many teachers are there. Okay. So I usually take interviews especially related to these machine learning scientists, etc., those type of positions. Usually IBM, the rule is that actually 2 tech rounds, mandatory minimum of 2 technical rounds will be there. So in technical round, purely if you qualify the first technical round, then only you will be promoted to second. Otherwise, there itself. Sometimes you will get some intimation, sometimes you won't get any intimation. Then once you fail, but there is no restriction, you are free to apply for some other jobs in IBM. But it is not the case with some other organizations. I think in Amazon, maybe after 6 months or especially in Google. Google minimum 3 months, after 3 months only will be able to apply that position. But IBM, it's not like that. Those who failed in one project, maybe they got hired in some other project. I have a witness. One person actually failed in the role of data scientist, which I took. But next month he joined a software developer there. Because I checked him for programming skills such as Python or etc. Because for handling data set, we don't require Java or C++. So, but he joined as a Java developer. That case is there. But anyway, so especially the roles related to technical roles, you can expect in the tech round, you can expect not only, take the case of these roles related to data positions. What I can share my case. What I do is that for that 1 hour will be the technical, 30 minutes I'll ask theoretical questions. Remaining 30 minutes coding. Yesterday also rejected one candidate only because of the reason that he joined in mobile. I asked him again and again to join through laptop. No. But when I asked how can you perform or how can you showcase your coding, then that time he asked, okay, my laptop is on. Up to that time he was saying that no, I have some complaint with that laptop, so I am able to join only this mobile. Then after 30 minutes I asked, okay, I want to check your coding performance. Okay, how can I check that? Do I need to arrange one more interview? No, my laptop is open. I will keep my mobile here. So its laptop is open, and apart from that, there are ways in different organizations to verify whether you are answering your questions by looking at Google or something like that. Because already they are tracking. Okay, so my humble request is that even though you don't know anything, please don't go for ChatGPT or some other Googling. Whatever, even interviewer knows you are not aware of all. See, I was for me, around 20-25 years experience. Okay. Now also, if you ask me something which I studied in my post-graduation, I may not remember that. That case is there. But see, especially those who are calling interview, those who are calling for the position of some data scientist, something, if you are confident, suppose you have confidently said, okay, I know Python, I am very much good in Python. Okay, fine. And I have also done so many machine learning projects. Usually I will ask that candidate, okay, which one you prefer? I can expect regression. Okay, then I will ask, okay, how do we perform a regression model in machine learning? Can you start coding? Take a notepad or free to open. Then that time he will say, okay, first line. Even he or she forgot pandas also. Why? Don't laugh. I know almost 80%, not 80, 90 also I can say. I'm not looking at the face. Simply I'm looking here, and 80% of the students have done this, a lot of machine learning projects you have done, but you have done simply copy paste. Am I right? Just skip that habit. Honestly speaking, especially in the coding interview, you may not get what to type. That is a problem. Not the case of pandas. Pandas you will remember, or scalar and all those things. But if you have this, I always advise, even during academics, that time also, I always advise my students, always do it from scratch. Please avoid that habit, copy paste. Okay, after hiring you can do it by ChatGPT. Definitely developers are doing that. They will take code from ChatGPT, but directly they will not get it, but after they will correct it or they will modify it. That is there, but especially attending the coding interview, beware of that. You will lose confidence, even you will not get that fluency. Always if you copy and paste, if you have that habit. You can expect coding not only in the position of developer role means full coding. 1 hour you can expect coding test. Okay, then this and one more thing, please try to avoid including all the skills in your resume. That interviewer itself will become confused. And One more thing, if you include all the skills in your resume, okay, by looking at that resume itself, we will get an idea, oh, all the skills are included. So most probably he may not aware of any of the things. So usually what I will do, I will ask, okay, which one are you fluent? Yeah, ma'am, everything is okay for me. I will ask them, you prefer your skill. Especially I am telling about the programming skills. Everything will be there. See, don't take it as a positive things by including all the skills. Suppose you have attended a workshop on what? R programming. Other than that, if you don't have any knowledge in R programming, please don't try to include that R in your skills. You can include it as attended a program workshop on something like that. So, because if you include something in your resume, definitely that interviewer will catch that. So, during attending interview, actually it's a luck. We have to call them in the sense, interviewer, to our comfort position. Then only we will be able to answer questions, right? So, for that, say for example, if you have done a good project by your own, that is very important. Not Google or not others. Definitely, especially in corporates, you can expect a question, what all projects you have done. Those who have attended interview definitely might have faced that. I faced it during my age of 45. See. But the thing is that if you have done that project by your own, definitely you will be confident to answer all the questions related to that, and you will be able to know what all things are there. That is why I said by your own. If someone else has done your project, or if you bought it by somewhere else, or if your friends have done, no. See, in that case, you will be in a comfortable position. Because that interviewer will ask questions related to that, you will be able to answer more questions. Because one criteria there, answering questions, some parameters are there. We will be given a score sheet. We have to fill that. See, suppose I don't like this interview, this candidate, I am not taking. I couldn't be able to take a decision like that. One thing is that recording there. That interviewer never, he or she, will never be able to take a personal discretion on that. Because lot of parameters are there, recording is there. Maybe suppose I reject that candidate, after some time he or she may send a mail, I have performed, I have answered all the questions, then why this person is rejecting me? If a question, an email related to that will receive to HR, I will be the one who answer first. I have to give the explanation for that. So, no interviewer will never purposefully reject the candidate. Only thing is that certain parameters are there, criteria is there. How many questions answered, or that rating will be there. Then your coding expertism, whether you are expert in coding. But coding, I am not saying that coding part is there for many organizations, especially I think Amazon or this Microsoft and Google, I am exempting. That is a different case. EY, TCS, everywhere I think coding test itself will be there. But for IBM it's not like that. 2 tech rounds. In that tech round itself, that individual will ask some coding, do some coding. Okay, especially the related to, but coding means it's not same for all positions. If you are applying for a developer positions, you can expect coding either in Java or C++ or something like that. But if you are hiring for a position of related to this data set, you can expect either in Python or R or something like that. Especially for business analytics or data analyst positions, even you can expect from some menu-driven softwares. Even if you are expert in Excel, that is enough. Or Tableau, Power BI, all those things. Because there actually data is analyzing, right? But especially related to machine learning projects, Python and R. At least Python. Very important. Then some theoretical concept. Theoretical concept in the sense, okay, I know I am very much expert in coding, whatever you ask, okay, I will do coding, but if I'll provide you a data set, if I'll ask you to do some data analysis, if you are not aware of the fact that what to do, what to apply, then what will be the situation? So that is why basic knowledge in some theoretical concepts also required. Okay. And one more thing, even though I am a data scientist, be frank to say that please don't think that there is no opportunity for Java or C++, etc., because this world actually is standing in a data science or AI world, right? Everyone needs to be a data scientist or AI engineer or machine learning scientist. We are not actually, be frank, we are not actually getting Java person experienced in Java or good in Java or C++. Last 4 years, not only Java, C++. CPP also we are not getting. Even last 4 months we are trying. Myself I can share. In my project itself, we are not getting a good candidate who is good in CPP. That is the case now. Especially, I'm not saying about all the organizations, but maybe some students are there. Oh, I don't know, it's very difficult to do this math, stat, etc. Don't worry. If you are expert in Java or like CPP, C++, all those things, no? Lot of opportunities are there. Okay, anyway, come to the challenges in AI. Actually, I think I have diverted. Okay, challenges in AI. What are they? Of course, AI offers countless opportunities. But it comes up with many challenges. Simply, availability of data. AI is only made possible with the availability of massive volumes and sources of data. Right? Even many organizations are there. We can see still paper-based. Take the case of medical itself. Many hospitals, even recording the patient records, they are doing manually. Patient records or appropriate scheduling. Even some organizations with digitized data or with digital information, they also have some limitations, such as they have limited access, or data is not consistent, or in a variety of format, all those things. That itself is a great challenge. Data quality. Ensure the data is right, complete and relevant. That is a challenge. Then lot of things are there. These are the words, these are the challenges, but specifically I am saying, for example, ethical considerations. Handling sensitive data responsibly and address ethical concerns. Ethical considerations. Then collaboration, bridging the interdisciplinary collaboration, bridging the collaboration between data scientists, then decision makers. Okay, maybe if the data, suppose a data handling person, a data scientist is handling a financial data, right? Okay, so if he or she is not aware of the various terminologies in that financial data, is it possible to come up with a, or is it prediction? Of course, he is able to come up with a prediction, but is it possible to do the last part, prescriptive analytics part, recommends an action based on forecast? No. So that gap between this data scientist, domain experts and decision makers, that itself is a challenge. No person can become a data scientist after studying all these things, because wherever data is available, it is possible to come up with predictions using machine learning or AI techniques. Right? Then, again, another thing I can say, the ability to understand how AI reaches its conclusion, or to know the reason behind how a machine learning arrives at a particular decision, particular conclusion. Actually, that one name is there, that part of that lack of transparency or potential bias which goes undetected, we call it as algorithmic black box. Have you heard about that? Algorithm, CS people, that's why I'm asking. Anyway, so that again it's a challenge. Then similar to that, no, then public trust and responsibility. No matter how AI advances, if the people don't have confidence in with the applications of AI are being trustworthy and are being implemented responsibly, then this technology is not going to have a wide adoption. Okay, so similar to that, lot of challenges are there. Yeah. Now, just move to impact of, ma'am, when through that break, any break is required? Okay. I think I will try to finish this part. Then after that, I'll explain with a case study. Okay, because during the beginning actually I shared you I asked you how many of you studied regression. So I will take a regression, but not training, testing, fitting regression. After fitting the regression model, what all things you need to consider. Okay, I will take second session, I will take that. But let me just say something more about this impact of AI on industries. Start with healthcare. Of course, it is like smart assistant to doctors by making healthcare more precise and efficient. Lot of things are patient predicting diseases, then perfect. Especially these, even though I am using the word impact of AI on industries, in most of the cases, we are using machine learning itself, machine learning algorithms itself. Then for something we are using some Gen AI techniques, etc. But Gen AI also actually some role of machine learning is there. Please don't think that Gen AI is entirely generative AI. Have you heard about that word? It is entirely different from machine learning, deep learning. No. It is only advancement. Okay, leave it to that. So in healthcare, actually, the role of machine learning is very, very important. Even IBM also, actually, I can start with that. IBM Watson. Anybody heard of that? IBM Watson Healthcare, actually, we have a software. So that actually employs AI to enhance this healthcare by personalized diagnostics and treatment recommendations. Even a lot of natural language processing. Watson's actually natural language processing capabilities, it enabled it to sift through vast medical literature. I couldn't say specifically mention one by one. So it's actually sift through vast medical literature and patient records to assist doctors in making more informed decisions. Even some contributions actually related to this Watson, I can say, for the previous years, 15% increase in the accuracy of cancer diagnosis. Then AI-powered recommended that average time to develop a personalized cancer treatment plan. Then 30% reduction in medication errors. This is purely, I mentioned here only the case of healthcare. I'm not saying that Watson X is used only for healthcare, no. Okay. Even now I can say I'm actually helping. I told you, yesterday I took a tech round interview that is for data scientist position in another project, Hyperblue. That is again a Hyperblue. Actually, they are actually trying to come up with a tool which is linked with Watson, but a better tool than this one. So it is not a feature advancement because anyway, some confidentiality there. Oh, really? Then I have to skip that. Okay, maybe this will be helpful. Okay, so this is that group is here. Okay. I don't know. Okay, are you using Watson X or just a study on? Okay, good. Okay, yeah. Don't imitate this. Anyway, I have included only a few points here. Don't say that Hyperblue project here. Actually, it's a confidential thing, but just as an advancement I shared. Because now you all people also, those who are trying to move to industry, you also people need to know what all things you will do in the future. Okay, developer role, of course, it is entirely different from this data science related positions role, and again it is different from see, sometimes if you are working in a product, especially like organizations like IBM, if you will be hired, definitely you will be working in some product. For example, I can say my responsibility, one of my responsibility I can say, even though I am a data scientist, please don't think that I am doing only data analysis part. No. One of the, have you heard about this software? Statistics, mathematics background people, if then IBM SPSS software. What have you heard about? Of course, it is an old software, 55 years back. But now also, I don't know whether you believe or not, this is one of the IBM product earning, or it comes top, especially regarding the profit. Among the 2-3 products, IBM is having more than 2,500 products. So among all these products, so this is one of the software who comes, I'm not saying that first position, top positions, I think third one or fourth one. Profit only, because in business, always aim to that profit. Yeah, why I mentioned reason is that maybe SPSS, if you ask someone else, maybe they will say, oh, it's an old software. But 55 years back, old software, I agree to that. But that appearance is not like this. That time, they will be having only few features. Right? But now it's not like that. Now it is not like that. See, this is one inbuilt data set I have chosen. Or here, if I click on this file, I have the option to import data from whatever be your size or format. Okay, anyway, basically the purpose of this thing is as doing statistical analysis. Okay, and machine learning also. IBM SPSS, two things are there. This is actually SPSS statistics. One SPSS modeler there purely for machine learning. Okay, anyway, I just want to share that, but it's not a free software. I'm sorry. Okay, so what I want to share that, suppose you will be hired for a position related to some product-oriented positions. Okay, you will be hired to a product-oriented positions. Then what you do is that, if you have a software like this, you have to come up with some innovative ideas for new features. Say for example, in this product, what my role is actually, while clicking analyze, this much things are there. Here while clicking analyze, some machine learning things are there. See, those who are aware of machine learning, is it related to that machine learning? Clustering. Tree means our decision tree. Then discriminant analysis, k-nearest. Is it a machine learning, right? Sorry, it's basically statistical thing, then only it comes in machine learning. So that is why, since this is a statistic, that was the thing I mentioned during the beginning of the session. Theoretical concepts are there from statistics. Okay, anyway, whatever be that, machine learning or statistics. So now we have only these much features. These things we call it as features. These meta-analysis, reports, power analysis, etc., etc. These are the features. So we have to come up with some innovative ideas, what all new things to include here. Actually, now we are doing an AI implementation. So every year we will be having at least one release. One release, one feature. No. Multiple features. Okay. So for that, if you are working, just I am sharing you that if you will be allotted to some product-oriented things, your duty include. I am not saying that this is the only duty. Your duty will include coming up with new innovative ideas to enhance the corresponding product or software. Okay, anyway. leave it. Okay, then, yeah. So we are actually standing, ma'am, I'll finish in 5 minutes. Okay. 3:30, is it okay? 3:30, okay. So just finish this PPT. So IBM, anyway, Watson. Now, other thing is Path AI. Have you heard about Path AI? So Path AI again utilize machine learning algorithms to assist pathologists in diagnosing diseases accurately. So what you do there is that by analyzing digitized pathology images, this Path AI system identify patterns and anomalies. Maybe sometimes those things human eye may miss. So definitely this analysis speeds up the diagnosis process to enhance the precision of, say, pathology reports by more than 10%. Definitely that also leads to better healthcare. Okay, so some contributions actually I mentioned here. 25% improvement in diagnostic accuracy compared to traditional manual evaluations. Anybody who took this topic? No, right? Yeah, this is also a good topic to study because machine learning algorithms are using there. Then reduce the time. Okay, then report findings by more than 50% or this decrease the rate of false positive. Also, a lot of results are there. I have included just 2-3 only. Now, next one is Siemens, another industrial giant. Embraces predictive maintenance through AI. They again using machine learning algorithms and analyze data from their manufacturing machines. Siemens also, I think you might have heard about this Siemens, right? Just I have included only some case studies. PayPal, online leader, leader in online payment, right? They are also using actually machine learning algorithms for what? To detect machine learning or AI techniques to detect and prevent fraudulent activities. They usually analyze transaction data, user behavior, like that. Those type of related factors just to identify suspicious activity. Okay. So some fraud detection. So many, even when you search machine learning project, you can see fraud detection using machine learning techniques. Some data or some even articles you can see by this PayPal's. Then some contributions I have mentioned here. Amazon. No point in explaining that. Lot of this machine learning scientist, AI position, data scientist position, Amazon is hiring nowadays. But the ultimate aim is to improve their business. That's all. Customer shopping experience, of course, shopping experience for its customers. Okay, heavily relies on this AI by personalized shopping experience to customers. Then browsing history, customers' browsing history, purchase history. Definitely that makes that product recommendations tailored to individual preferences. And even that analysis actually has contributed significantly over Amazon success and customer satisfaction, especially by reducing the service response time, customer service response time even more than 40%. So some contributions I have included here. This is also a good topic I recommend because lot of studies are there nowadays. Contributions are there by Amazon. Then Caterpillar. This actually support the agriculture industry, especially to detect. They are also using machine learning algorithms, especially help farmers to identify the maintenance needs or prevent this, during critical season, shutdowns or breakdowns. So prior to that, they are able to predict. Okay, so all those things. Caterpillar, actually it's a constructive and mining equipment manufacturer. I think you know this. Here Bangalore itself, I think, no, Kerala it's not there. Okay. Bangalore Caterpillar, some of my friends are working. Yes. Yeah. One of my close friend is working as senior data analyst there. Yeah, Uber also. Uber, lot of positions are there, senior data scientists. Even recently, I took a tech round for Uber also. In US, actually, Uber data scientists are getting high salary than even Google. Really, Google and Microsoft. One of my close friend recently shifted to from Microsoft to Uber. Uber. Just imagine that situation. He is actually getting around, I think, 80% hike. Existing salary from Microsoft, he was getting 80% hike. Just imagine that situation. Uber means, but maybe in I don't know here also, maybe those who are, so if somebody will ask, where are you working? Uber. Oh, Uber. No. We are actually working as higher positions, not as a driver. Okay, so anyway, Uber also actually uses this AI techniques or machine learning techniques to optimize ride sharing and delivery routes. So especially by considering, I can say, driver availability, then real-time traffic incidents or passenger demand, just to provide some efficient and cost-effective transportation services. Anyway, case studies, I am stopping with this, otherwise you feel bored. Okay, I think now after the break, I will move to, okay. So if you have any preference for the hands-on session or some topic, no issue. Lot of PPTs are there with me. Is it fine? Because that basics of regression almost everyone knows. That is why I thought of sharing some. But I am not going to the base, how to develop regression models. Nothing. After developing the regression models, what all things to consider just to improve your model. Is it fine? Okay. Are you feeling bored? Not teachers, students. Be frank, if you try to interact with me, during the beginning itself I mentioned I don't want to take some session in a very higher level. I usually speak only these basic things. Because you will not get some points that I mentioned, you will not get even while reading or Googling or nothing. Okay. Ma'am, just up to what time? Okay. Okay. So, okay. So, I'm skipping these basics of machine learning. So, as I mentioned previously, almost all of you are aware of regression. So, simply fitting a regression model or how to make predictions using regression model, what you do is that, especially as a machine learning project, we will divide the data set into two, training and test. Okay. First, we will train the machine using, what is the procedure behind machine learning? I think all of you are aware of that procedure behind. How many of you have not studied machine learning? Not studied machine learning. Teacher, these people I know. Yes. Okay. Anyway, just 5 minutes on the intro to machine learning. Here actually, machine always learns from experience. Simply, some definitions are there by various authors. Simply, if you are asked to, or if you want to teach a child, simply I can share with an example. Simply, if you want to teach the a small child using images of different fruits. Suppose you are given a set of fruits, images of different fruits such as apple, orange, etc. So what you do is that you will pick up the first one, take the first one, ask that child, tell that child this is an apple. Then take the second picture, Tell that child, this is an image, this is an orange, something like that. But one confusion there, simply if you want to teach that child different fruits using those images, of course you can take one by one. Then after finishing all the images, all the pictures, the child is having some pattern of or some idea of each of those fruit in his mind or in her mind. Right? So those set of pictures which we use to teach that child, we call it as training data. Okay? After teaching that, of course, we need to check whether the child learned or not. Just like teachers teaching students. Okay? What you do? We will take some examination, something like that, right? So here also, we will take another set of data known as test data. Of course, the images of these fruits itself, then we will ask that child. So here, the machine actually works in the similar manner. First, we start with training data set. We will try to train that machine using the data, so as to come up with a model. In the case of child, that learned child is the model. Okay? Then after that, we will take another set of data. We need to check whether the child learned or not. Same case we are doing in machine also. We have to check the machine learned or not. So for that, what you do is that we will take another set of data. We will check the performance of that. In case of child, to check the performance, simply we can ask. If the child answered correctly, say new set of test data, 10 pictures. Out of 10, if he answered correctly, 8 answers correctly or 9 answers correctly, then we can conclude that the child learned to distinguish between apple, orange, banana, etc. Same case machine also. If the machine will give you, say, above 70%, usually we take above 60% as good. It depends on data, because if you are dealing with large sets of data, 60% is enough to use that machine for future predictions. Okay, so that is a procedure in machine learning also, just like the same manner as a child learned about fruits. And one more thing, suppose you are given, same example itself, suppose you are given, say, 1,000 images, right? 1,000 images of different fruits. So if you are planning, or if you are started teaching a child, first one orange, second one apple, third one banana, fourth one pineapple, child may get confused with that. So it is better to teach that child with a collection of pictures of oranges first, then with a collection of pictures of apple first, then banana, grapes, etc., etc. So in that case, if you are given a mixture of all these images, first you need to divide those pictures. Apples as one group, oranges as one group, then banana as one group, pictures of banana as one group. For that itself, we have a type of machine learning known as clustering. Okay, first divide those pictures into different groups, where each group is having some similarity. Definitely, if you collect those pictures of oranges together, it is having some similarity. All are oranges. And then another group with apple, shape, color, everything same, right? So some similarity. So in clustering, it is mandatory to group these. Actually, that group itself we call it as clusters. And just an addition, clustering is not a new topic in machine learning. It's a century-back method in statistics. Okay. So anyway, this clustering actually comes under one type of machine learning known as unsupervised machine learning. Okay. But if you are predicting the image of a fruit as orange or pineapple or something like that, that comes under supervised learning. So 3 types of machine learning are there. Supervised learning, unsupervised learning, and reinforcement learning. Okay, here in this picture actually I have included one additional thing, semi-supervised. If you skip that, then also it is right, it is fine, because semi-supervised, it's a combination of supervised and unsupervised. Okay, so the child example, first one actually purely it is a It is an example of supervised learning. Usual procedure. Start with a training data set. Train that. I can show you this. Look at this example. See, I have a set of pictures. Okay, some pictures. Those pictures are labeled as one as rectangle, circle, triangle, etc. One of the conditions for supervised learning is well-labeled data. Okay, so we pass that labels or that data to the machine. It will give you a model. Applying some methods. Yeah, what is the role of stats there? In the case of child, we are there to teach that child. But while passing this data to the machine, we need to pass some statistical methods or statistical techniques for learning. Okay, so as to come up with a model. That will give you a model. Okay, then we need to test that model. We don't know whether that model is correct or not. So we pass some test data to that. That will give prediction based on the accuracy. And again, that word accuracy, it is different in different techniques. Say for example, in this example, we have different categories such as rectangle, circle, triangle, hexagon, different classes. So this is an example of classification problem in supervised learning. Now you can ask me, other than classification, what all things are there? Yes. Again, supervised learning is classified into, where is that? Yeah, that slide is not there. Actually, this is not a machine learning slide. This is actually, I just prepared for, just a minute. Yeah. 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 So first, types of machine learning, 3 types: supervised, unsupervised, and reinforcement. Again, supervised learning is classified into classification and regression. So classification models are used when the output is a category. Yes or no, pass or fail, dog or cat. Or if you want to predict whether it is an apple or orange or pineapple or banana or something like that, we use classification models. And please don't think that there is only one classification model. No. Lot of algorithms are there under classification models, such as decision tree, support vector machine, then logistic regression is the first one which we are using. Decision tree actually can be used as classification model and regression. What is regression? If your predicted thing is a quantity, numerical quantity. For example, if you want to predict the weight of a person, height of a person, temperature, tomorrow's temperature, then exam score obtained by a particular student. So if it is a numerical quantity or continuous value, we use regression. Okay, classification means category, prediction of category. So if you are given a set of pictures of me, if you want to predict whether the new picture is the picture of Bindu or not, then it comes under classification techniques. Now that is the first category. So in the previous example, of course, that child case, predict whether this is an apple or not, that comes under classification. Then again, unsupervised learning. Unsupervised again classified into clustering and association. What is unsupervised? I can show you this. Look at this example. This example already I mentioned, this is purely an example of supervised learning or an example of classification problem model in supervised learning. Because here finally we need to predict whether it is a triangle or circle. Category, right? But same example itself, we can treat it as an unsupervised. See, you are given a set of pictures, no labels. If you want to apply some unsupervised learning technique here, what you do is that, say, clustering. Okay? So we divide, or that procedure, that algorithm divides those pictures into different groups where each group is having some similarity. We are not aware of what is the name of those things. Some similarity there. Look at that result. So here actually not a prediction. But in the same problem itself, after applying unsupervised learning, you can apply some supervised learning. Case of that child example. First apply unsupervised learning or clustering to divide those fruits into different categories. Then try to teach that child. Finally, using a test data set, predict whether the new thing is apple or not, or orange or not, something like that. Okay? Anyway, go back to... Okay. So types of machine learning. Supervised learning, unsupervised learning, already I shared an example. Now reinforcement learning is nothing. Here actually one agent will decide how to perform that. Say for example, this is an example, say some robot here. Suppose he needs to catch this diamond. He can go through this way or this way or this way, different ways are there. Right? So what you do is that, or how to catch this diamond after overcoming all these hurdles with minimum time, minimum cost, etc., etc. So for finding that, you can use reinforcement learning. Game playing chess to predict the winner, you can use this reinforcement learning. Okay. So I don't want to stick much on the basics of machine learning due to limitation of time. That's all. Otherwise, no, machine learning, when I start this, it's a weakness from my side. I become more excited. Sorry. That much interest for me now also for this particular thing. Be frank. Even yesterday also I shared, yesterday FDP, yesterday and day before yesterday, 2 days, I was not able to finish all the machine learning techniques. Because now, while picking a machine learning algorithm, lot of things are there to share. Okay, anyway. Before moving to regression, see, I think this is one of the machine learning algorithm in supervised learning. This is a classification technique. Okay. Almost all of you have studied Bayes theorem in your school classes, right? This is those who have not heard about machine learning. This is an algorithm based on Bayes theorem. Okay, Bayes theorem, maybe you might. Oh, again I need to take the other one. Sorry, I closed that. Right? Where is that ML? So as I mentioned, under those supervised and unsupervised, lot of algorithms or lot of techniques are there. For example, Bayes is a classification model in supervised learning. Then linear regression is a regression technique under supervised learning. Again, logistic regression, please don't think that logistic regression, name regression, but it is not a regression technique. It is a classification technique. That means it is possible to predict whether this or not, this or that, using logistic regression. Then why that name logistic regression? It has a connection with linear regression. So many people are here who studied these things, linear and logistic regression. Can you say what is the relation between logistic and linear regression? Anybody knows? Anybody? Anyone? What is the relation? Why that word regression comes in logistic regression? Are you aware of the fact that logistic regression is a classification model? Output is 0 or 1. Okay. But my question is, why that word regression comes? What is the relation between linear regression and logistic regression? Okay, I'm not wasting time. You know that? Okay, no, not an issue. See, logistic regression actually functions based on based on this equation. Okay? Those who Studied logistic regression, of course. Familiar with what is a sigmoid function. What you do is that, okay, if the value lies between 0 and 1, if it lies above 0.5, this is the prediction. If it lies below 0.5, this is the prediction. Actually, there is a relation with this function. This is a probability. Or if you substitute any value for z, any value, you will get a value. On simplification, you will get a value lies between 0 and 1. That means it's a probability. Okay? So usually what we do is that in that figure, for example, if the final value of that function lies above 0.5, then the prediction is an apple. If it lies below 0.5, we are making a threshold. Okay. Anyway, my question is, what is the relation between this and here? This is Z, right? Z is same as our linear regression model. That is y equals ax plus b4. Okay? Same as our linear regression. But only thing is that when you substitute here ax plus b or beta naught plus beta 1x, etc. on simplification, you will get a value lies between 0 and 1. But in regression, you will get different values. Okay, anyway, back to regression. Otherwise, I won't get time. Not regression, just I can quickly review that. Naive-Bayes. Where is that? Naive-Bayes. It is strictly based on Bayes theorem. Maybe in school classes you have done problems with there are two identical bags, one of which contains 3 white balls and 4 black balls. Other one contains so and so. A white ball is drawn from one of the bag. What is the probability that it comes from the first bag? How do we connect that question? Are you familiar with that question? All of you attended this now. How do we connect that with the machine learning algorithm Naive-Bayes classifier? Look at this example. Where is that? Okay. I think you have studied this formula, right? Probability of A given B into denominator one lengthy term. P of A equals, see, expansion I have written in this equation 16. Okay, anyway, look at this. Look at this question. Here, a data on code review duration and defect density for 10 or 12, whatever be that. So I have a set of values. Only thing is that I have to predict defect density. When review duration is low. Look at the question. Predict the defect density. Just I have given us a case study, that's all. Predict the defect density for review duration is low. Predict using Naive-Bayes algorithm. Okay, how do we predict it? See, look at that defect density. Review duration low. Review duration low means this. Right? What is the defect density? For these values, we have 3 options. High, medium, low. We have to choose best. We have to find the best one among these options using Naive-Bayes. Simple thing. Find the probability that defect density is high given that review duration low. Find the probability that defect density high, review duration low. First probability. Again, find the probability that defect density medium when the review duration is low. Again, find the probability that defect density is low when the review duration is low. Same case you are finding in the case of that. You have 3 bags or 2 bags. Find the probability that it comes from the first bag given that this way. Find the, you have done only one part, but here for finding the best one, you have to find 3 cases. Find the probability that it comes from the first bag given that it is right. Find the probability that it comes from the second bag given that it is right. Find the probability that it comes from the third bag given that it is right. Which one is maximum? That is here also. Okay. So here, see, probability that defect density low, if we denote defect density by y and review duration by x. So low given low. Second case, defect density medium when review duration low. Third case is when defect density high, review duration. Find these 3 probabilities, 0.17, 0.5, 0.3. Which one is maximum? 0.5. So the best one here corresponding best option for defect density corresponding to review duration low is medium. See, here, these things actually, it is very easy to get it from this table because only 12 rows are there. But instead of these 12 rows, if you are given 12,000 or 12 lakhs, is it possible to find these three things? Or even if you have more options here, is it possible to find directly? So actually, these things are obtained, even though here we can obtain it directly, but actually that is based on this formula of Bayes theorem. This one. Okay, so while dealing with large data sets, definitely with a single word naive Bayes in Python programming, you will get this model for prediction. Okay, got it? How do we predict using naive Bayes? Not only naive Bayes, another thing, simple things I can share you. Yes? Yes? Something to ask? Okay. Take the case of decision tree. I think all of you heard about decision tree. How do we make predictions? Decision tree, it's a purely computer science topic. I can say mathematics, but I don't know whether you will agree or not. Anyway, whatever be that. Decision tree is used for both classification and regression. That means if you want to predict whether this is an apple or not, it is a classification model, you can use decision tree. Or if you want to predict the temperature or tomorrow's temperature, it's a value, you can use decision tree. But what is the concept behind that? Using the data set, you have to create a tree. Okay? From that tree, make predictions. Start with a simple example. See, one example, 3 variables, x1, x2, y. The remaining thing is just continuation of that. Only 3 columns. x1, x2, y. These 3 are just continuation of this. Just to fit it in a single PPT, single slide. Okay, so we have 3 variables, x1, x2, y. So we have to predict y. Suppose we have to predict y. Look at the options of y, blue and red. Okay, suppose I am asking you what is y when x1 equals 10, x2 equals 30. What is y? When x1 10, x2 30. Is it there? No. We are going to find it using decision tree. Okay, simple. Draw a graph by taking x1 along x-axis, x2 along y-axis. Say for example, first value 11.35 along x-axis, 23 along y-axis. You will get a point, right? Mark it as blue. Okay. Similarly, mark all combinations like this. Okay. A 2-dimensional graph, that's all. Simple. Okay. Now, draw a line that separates blue and red points. Draw a line that separates blue and red points. Not possible to separate it with a single line. See, here I have drawn a line. Of course, this portion only red, fine. But look at this below portion. Combination of red and blue. Again, draw another line. But before drawing another line, see, here we have only red points, right? This, above this line, we have only red points. This line corresponds to 35. Around 35. So, if x2 greater than 35, we have only red points. Just mark that. x2 greater than 35, we have started the tree. x2 greater than 35, we have only x1. Again, I have drawn another line. Look at that line. Below that line, we have only blue points, right? So, corresponding to this line, we have some 28. So, for x2 less than 28, only blue points. Again, we have a region between combination. Yes. No, here if you draw a line, no, we cannot separate. If you draw again horizontal line, we cannot separate. Vertical line. Okay. Now look at this region. But when we draw this vertical line, see, this is somewhere 15.5. For less than 15.5, I have only blue. For greater than 15.5, I have only, see, this portion, don't bother about these two portions, you have already separated. Now look at the middle portion only. I have drawn a line. So this portion blue, this portion black. And this line actually corresponds to 15.5. So 15.5 is x1, not x2. So for x1 less than 15.5, we have blue. For x1 greater than 15.5, we have red. That also I have marked. Now, is there any region which is a combination of red and blue? No. Now, just answer my question. What is y when x1 equals 10, x2 equals 30? x1, see, here our tree starts with x2. So, whatever be the order in the question, we need to start with checking for x2. x2 equals 30, right? x2 30 means here or here? Less than 28? No. 30 not, is not less than. Greater than 35? No. So we have to look at this part. Okay? Depends on x1. Look at the value of x1. x1 10. x1 10 means less than. So answer is blue. But suppose predict y when x1 equals 10, x2 equals 40. x2 equals 40, x1 10. x2 equals 40 means it comes in this region, right? Greater than. Irrespective of the value of x1, prediction is red. You don't have to look at x1. Got it? Now, this prediction is possible only if you have limited data set and with 2 variables. Okay? So, suppose you have 20,000 variables with 20 lakhs data set. This is not possible. So in that case, we approach an algorithm. That is, these are the challenges here. How to represent entire information using minimum number of rows. Number of rows means this one, these lines. Okay, minimum number of rows. Then how to develop the smallest tree. All those things. So there is an algorithm known as ID3 algorithm. We are using ID3. There actually we use the concept of entropy. Have you heard about entropy? Entropy. Measure of information. So a lot of things are there. It's a measure of actually uncertainty. How to measure of, it's again from statistics, but if some chemistry or physics people are there, they will argue, oh no, entropy is ours. Okay, leave it. But we have in statistics some types of entropies are there, some Rennie entropy, Shannon entropy, etc., etc. Anyway, whoever be the owner of that word, we are using this concept in this decision tree. So what we do is that we will find entropy, using that entropy corresponding to each node. Using that entropy, find the information gain using this formula. Then those having maximum information, we will pick up. So for the above example, actually first while calculating this, you will get maximum gain for x2. See here actually we started with x2, right? So maximum gain for x2. We will start with x2. Again we repeat this process. From the remaining one, find the maximum gain. Choose the next node as that one. Like that we will proceed. It's a lengthy procedure. Okay. Anyway, so that is the case about decision tree. Then similar to that, other k and k nearest neighbor, etc., etc. But I am going back to regression because otherwise I can't finish that. 1 second. 1 second. It came from this Slack. Since I joined here, actually, Slack is actually, we are not supposed to use, not only me, we, those who join some industry, we are not supposed to use WhatsApp for official communications. Slack is an app for that. So if some emergency messages will come, I actually already set a pop-up. So by hearing that, here actually I disable because just to keep policies, integrity, all those things while using this laptop for taking classes, unofficial purposes. Okay, anyway, leave it. Yeah, moving to regression. Regression, those who are not aware of regression, 2 sentences on that. Simply, if you want to predict some numerical quantity based on some other variables. Okay, simple example, years of experience, salary. Suppose you want to predict the salary based on years of experience. Predict the salary of a person based on the years of experience. See, if I want to predict the salary of a particular person, if he is having 20 years experience, is that 20 here? No. Okay, so you can use one of the method which can use this regression, that's all. I am not saying that if you have only 2 variables then only it is possible to apply regression. No. If you have only 2 variables like this, one variable, here it is, if we are going to predict salary, that we call it as dependent variable. Remaining variable we call it as independent variable. Here salary is the dependent variable, years of experience is the independent variable. If you have more than one independent variable, then that goes to another type of regression which we call it as multiple linear regression. This is an example of simple linear regression. Okay, if you have more than one independent variable, that goes to multiple linear regression, and the mathematical form for simple linear regression is simply y equals mx plus c form. Okay, just I have given some notation beta naught beta 1, simply y equals ax plus b, same thing. Beta naught plus beta 1 ax plus b, just reverse that all, that's all. But if you have more than one independent variable, we will extend it to beta naught plus beta 1 x1 plus beta 2 x2 etc. Take this example. See, you have 3 variables. I am going to showcase the practicals using this data. 3 variables: time, temperature, yield. Suppose you have to predict yield for a new value of time and temperature. Look at this question that I have included as a case study. Effect of temperature and time affect the yield. Develop a model for percentage of yield. Suppose you have to, I am not saying that it is possible only for prediction of yield. No, you can predict time based on temperature and yield, or you can predict temperature based on yield and time, anything. Assume that we have to predict yield based on time and temperature. 3 variables are there, so it goes to multiple linear regression. Okay, so look at this model. This is the model. So if you are going to predict yield, the model becomes yield equals, you will not get this form of model from the practicals. Wherever you copy and paste, you have to learn this. Okay, model of linear regression. So yield equals beta, constants can be notation anything, beta naught plus beta 1 into time plus beta 2 into temperature. Okay, independent variables right side, dependent variable left side. Now our aim is to find beta naught, beta 1 etc., which we call it as estimates or parameters or some unknowns. Because once we get the value of beta naught, beta 1 etc., then only you will be able to predict a new value of yield. Okay, so this is the model. Right? Find the values of beta naught, beta 1. In Python, if you are using Python or R, whatever be the programming, in Python, after importing the sklearn module, with a single word linear regression, you will get all these things. Then after that, what you do? You will check the accuracy of that model. Predict. You can predict, of course. All these values, say for example, in the new model, actually you will get it like this. No, somewhere right. Okay, I will show you in practicals. So anyway, you will get values of beta naught, beta 1, beta 2. Then after substituting beta naught, beta 1, beta 2, if you substitute any value of time and temperature, it is possible to predict yield, but you are not sure that that is correct or not. For that, check the accuracy or mean square error. What is mean square error? See, this is the model of, anyway, I think I can move to the practicals. Right. Do I need to open Collab or is it fine with Jupyter Notebook? Anyway, you are not doing it, right? I am explaining only because due to time constraints. Anyway, let me explain with the Jupyter Notebook. Otherwise, maybe if some network issue will come, it will take time. Okay, Jupyter is enough for doing machine learning. But if you are dealing with, say, up to 12 GB, it's fine in Jupyter Notebook. I usually take this, or especially while delivering sessions. Otherwise, no, at a time, especially while taking hands-on sessions, no, even though Wi-Fi is very, very fast, but Same time all are using. So we can expect some delay. First person will complete the first step, that time second person will complete the 10th step. Okay, anyway, here I am explaining only. Okay, just look at this. First let me start with, okay. See, same data set. So before importing data set, with the hope that all of you are aware of basics of Python. Okay, so for importing data set, first we need to import pandas. Then here I have imported some libraries. First one, matplotlib. What is the purpose? For diagrams and graphs. Seaborn, again for diagrams and graphs. Then the third line is purely for sklearn. Sklearn or scikit-learn, S-C-I-K-I-T, scikit-learn is exclusively for machine learning. Okay, from sklearn dot linear model, because we are going to deal with this regression linear model. From that, import the package linear regression. Okay, in case of logistic regression, only difference is that from sklearn dot linear model, import logistic regression. Okay, anyway, last one is actually mean square error. I mentioned previously, whatever be the machine learning model you are going to develop, after developing that machine learning model, you have to check the performance of that model. One of the performance measure for regression is mean square error. Nothing. What is mean square error? If you import this package in a single line code, you will get that. But what is the concept for mean square error? See, this is our model. Okay, so after getting beta naught, beta 1, beta 2, etc., if you substitute any value of time and temperature, it is possible to calculate yield. Suppose after getting beta naught, beta 1, beta 2, etc., I am going to substitute each of these values. Time equals 130, temperature equals 190. You will get a value, right? So that is the value, predicted value corresponding to first row. Similarly, you can find the predicted value corresponding to second row, third row, etc., etc. Okay. So just prepare a column like this. Time, temperature, yield. Given data. Predicted means using the obtained model, we have calculated predicted. Simply take the difference between these two. Difference between these two. Just think logically. That is the error, right? Actual minus predicted or predicted minus actual. See, but this error or residuals. Error itself we call it as residuals. But look at this last column. It's a combination of negative and positive. It's not able, we are not able to say how much error is there or not. So what we do is that we will take the square of that. Then again taking the square, you will be having a set of values. You have to get a representative value to reach a conclusion. Take the average of that. Average of square of error, which is same as our mean square error. Mean square error. Maybe you might have studied it as a cost function, loss function. Same thing. Average of square of error, which is same as cost function or loss function in regression method. Maybe some of you have studied it by, the ultimate aim of ultimate objective of regression is to optimize the cost function or loss function. Actually, we are doing it this thing. We are trying to minimize the error. So one of the performance measure of regression is this one, mean square error. But one drawback there, while getting a mean square value, mean square error, you may not be able to predict or say whether this is good or not. Because mean square value, it is a square, of course minimum value is 0. So logically speaking, if it is near to 0, it's a good model. But I am asking you, suppose you are handling 5 lakh data set, and if your mean square error is 1 lakh or 5,000, you will reject or continue for prediction. Suppose you are dealing 5 lakh data set and you obtain the mean square error as 5,000. Oh, 5,000, it's a large value. Oh, my model is not good. Please don't take a decision like that. Because now while getting mean square error purely depends on your data set. Definitely when your data set increases or number of samples increases, mean square error increases, no doubt in that. So that is why during the beginning of the session I shared, we are not supposed to make a decision only based on this mean square error. Lot of other things are there. Even one area is there in statistics or in regression known as error analysis or residual analysis. Okay, usually in machine learning what we do is that, okay, mean square error, then you will find the dot score. accuracy. Is it right? I'll show you. Yeah. See? Okay. So after importing all those corresponding libraries, then import the data. I have imported the data set. Then these are optional actually. Dot describing just for getting mean, median, mode, etc. Even though I am saying optional, it would be good to find this also. Simply at least for checking whether there is any missing value or not, outlier or not. See, simply missing value can be traced out from this first row. Here 16, 16, 16. That means all the columns have 16 values. Suppose these values are different. That means there is a missing value in, say for example, if you have 15 here, then there is a missing value in temperature, in the column temperature. So this is one of the way for identifying missing data, or otherwise you can check the information of data, dot info. But anyway, these are optional. Then just, okay. So before fitting the regression model, definitely we will rename all the independent variables. For example, here time and temperature are independent variables. So we have all together give a new name. Okay. So here I have given the way X, name X. Time and temperature together. What are the independent variables? Together give a new name. That's all. Then also I denoted Y as yield. Then develop them. This is simply I took the scatter plot. Even though these things are optional, it is good to do these things also as a preliminary to the regression analysis. Reason is that, what is this? This pair plot means nothing. See, we have three variables, right? Time, temperature and yield. Just get a plot by taking time along x-axis, temperature along y-axis. Time along x-axis, yield along y-axis. Or yield along x-axis, temperature along y-axis. All together you will get by taking a pair plot. So from this plot, maybe if you get some shape in this plot itself, you will be able to say, yeah, there is a good correlation between these two variables like that. So you will be able to interpret like that also. But anyway, again, it's optional. Then next thing is find the correlation between variables. Correlation. Simply CORR. See, look at this. For example, this is the correlation value between minus 0.00756 is the correlation value between time and temperature. Or this 0.8967 is the correlation between yield and time. See, there itself even you can interpret there is a high degree of correlation between yield and time. So, one side you can say it is good to use the variable time for prediction of yield. That also another thing. See, suppose you are given say 20 variables and you are asked to predict the yield. 20 variables and you have developed a regression, multiple linear model like this. You cannot say that all these variables are good for prediction of yield. There are ways for checking that. For example, here actually I have used time and temperature for prediction of yield. But it may not be necessary that always both variables together will give you a good prediction for yield. Sometimes if you skip time, you may get a good prediction. Or sometimes if you skip temperature, you may get a good prediction. Okay? Same case here. See, by looking at this value, since here two variables only, time and temperature, so it is very easy to trace it from this correlation itself. But while dealing with a many number of variables, definitely you need to cross-check that. There are methods. I'll come to that. Okay. Anyway, so we are standing only in correlation. Now we are fitting the regression model. See, only 2 steps. Develop the model, provided you have imported this sklearn package. Here we have already imported sklearn package, so simply regression. Right? Linear regression. And don't forget to fit with your data set. Develop the regression model. Just I have given a name. My model is the name which I have given. You are free to give any name of your own choice. So dot fit. Fit with those variables, independent variables and dependent variables. Now, After fitting the regression model, is there any formula or is there any value of beta naught, beta 1, etc. visible here? No. So for getting that, dot COEF, coefficients. Coefficients of time and coefficients of temperature in the order in which data is there. Okay. Then intercept. What is intercept? Beta naught, first term. Okay, again go back to school class. Intercept and slope. Y equals mx plus c form, right? Slope mx plus c. Slope mx plus c. M is the slope and c is the intercept. That figure is also there. You know what is slope and intercept, but I am asking you from a graph, how do we detect the slope and intercept? See, if you have a graph like this, this is the intercept, this measure. Okay, slope means, see, from this line, see, difference in y coordinates divided by difference in x coordinates. This b1 is same as our beta 1. b0 is same as our beta naught. Okay, now go back to this. So here coefficients, intercept. So this is the coefficient, or this is the value of beta 1, this is the value of beta 2, and this is the value of beta naught. So we obtain the model. It is very easy to predict. But for that we have to check the performance. See, R square value. Previously I mentioned R square value is equivalent to accuracy in regression models. What is R square value? The variation in, how much variation in dependent variable affected by variation in independent variable. So we are measuring it using a formula. That formula actually closely related to ANOVA in statistics. Have you heard about ANOVA, analysis of variance in statistics? Those who have heard about ANOVA, they will understand this thing. See, residual sum of squares, total sum of squares. So I think you are hearing this R square first time. Formula for R square first time. Because you studied this as accuracy for machine learning, right? Am I right? That accuracy in regression model actually we call it as R square value. It is obtained by 1 minus residual sum of squares by total sum of squares. Don't worry about these jargons. Total sum of squares means this is the expression. See, suppose your values are denoted by y1, y2, y3, etc. Find the average of all those values. Find the difference between each value from its average. That is y minus y mean. Take the square of that, add that. That itself total sum of squares. Similarly, this is actually error sum of squares, which you have already calculated. Okay, so R square is obtained by 1 minus residual or error sum of squares divided by total sum of square, which is a value lies between 0 and 1. So definitely if you multiply by 100, you will get it as a percentage. So that is why you have computed this as accuracy, accuracy, accuracy. Because classification model, we are using dot score as the syntax for getting accuracy. Same thing we are using in regression model also for getting R square value. But in regression, it is not known as accuracy. Instead, it is known as R square value. So variance or variation in dependent variable can be affected by independent variables. Okay, it lies between 0 and 1. Usually, if it is above 0.5, you can accept. You can conclude that your model is okay. If it's near to if it's near to 1, it is very good. It's a perfect thing. If it is 1, near to 1 means it approaches 100%. Okay. Yeah. Next thing. Before that, practical sides we are see, we are actually standing here. Dot score. Dot score means, dot score is the syntax used for finding accuracy or R square in. I always suggest don't use the word accuracy in regression. Use the word R square. But in classification, of course, you can use the word accuracy. But anyway, this code is same for both. Okay. Then I have multiplied by 100, rounded. Yeah. So prediction. How do we get these values? By substituting each pair of time and temperature in our obtained model, you will get a value. Predicted values. I showed you in that PPT, right? A set of predicted. Those values are same as this thing. Okay, then mean square error. 1 not 2. Is it good or bad? Is it good or bad? We cannot say. So that is why I suggested previously, don't skip this R square value. Because from the mean square error, you may not reach a situation, you may not conclude whether your model is good. And in addition to that, I am saying that these are not the only ways. Say for example, error analysis. Error analysis is again part of, again move back to 5 o'clock. Sorry, 5 minutes, I'll finish. Okay, see, these are the assumptions of regression. I'm 100% sure, 100% I'm telling you that those who have done regression or machine learning project, regression machine learning project, never heard of these things. Is there anyone who checked any of these conditions? Those who have done regression project, I am asking. No, usually that happens, especially in machine learning. That's a drawback, be frank. The thing is that I'm not saying that as I am basically a statistics person, no. So actually our ultimate aim is to get the model as good as possible or as better as possible, right? So try to check all these basic conditions as much as possible. First condition, it is very easy to check it. See, linearity, it is understood, nothing to check because we are actually making the linear model. But the second thing, independence of errors, normality of errors, equality of errors, that is this error value. After getting this error value, where is that? Yeah, this last column, residuals. For getting the interpretation as your model is good, you have to check whether these errors are independent, one thing, or these errors are normally distributed. Lot of ways are there for checking this normality. Normalization. Simply you can plot a graph using these values. Bell-shaped curve, normal distribution, Gaussian distribution. Same thing I am telling. Gaussian distribution. So error should be normally distributed. So simply draw the graph of that. That is one way. Most of the cases you will not get a normal curve because we are not dealing with simple values. We are dealing with lakhs or millions of values. So what you do is that you can check it for normality. Diagrammatic or visualization techniques are there for normality. Statistical test of hypothesis are there for normality. Say for example, see, have you ever heard about this PP plot, probability plot? This is one of the method for, see, one single code. This part you can skip. This part you can skip. Stats.prob plot. Import stats. Before that, import stats, one package. Yeah. From SciPy. Scientific Python. Have you heard about Scientific Python? Okay. From SciPy, import stats. Okay. Then draw this PP plot. See. Then how do we make the conclusion? If the values, those blue points lie almost along that straight line, then we can say that data is normally distributed. Okay, this is one way for checking normality. PP plot. Again, similar to that, PP plot means probability plot. Similar to that, one more plot for checking normality. QQ plot. Quantile plot. You will get the same shape. Just a plot like this. So these are the two methods. These are not the only methods. You can check statistical test or some test of hypothesis there. Shapiro-Wilk test, then Anderson test. I'll show you the PPT. Anderson-Darling test, like that. Yeah. Shapiro-Wilk test, Rand-Joyner test. Only 4 tests I mentioned here. These are not the only tests. Mardia test, Hensey circular, etc., etc. Lot of tests are there. Statistical test of hypothesis. Have you heard about that? Anyway, some tests are there for checking normality in statistics. Okay. So for checking the normality of errors, you can adopt any of these methods. But here, we assume the null hypothesis that always, whatever be the test which you are choosing, null hypothesis is data follows normal. Okay? Then, usually if p-value less than 0.05, we reject the null hypothesis, right? Simply keep this in mind. If your p-value, if you are using any of these tests for normality, if your p-value is greater than 0.05, then we accept, or then the data is normal, that's all. So, go back to here. See, here. Normal test, okay, stats normal test. So here I am getting some p-value somewhere here. Yeah, p-value 0.37 greater than 0.05. So data is normal, errors are normal. So this is another way for checking normality. Again, some other regression techniques are there. After getting your regression model, plot the actual versus predicted. Okay, if there will be any pattern for that, your model is good. This is another method for checking. If there is some pattern, here I am not saying that exact straight line, but it is okay. Okay, then next method. See, plot predicted versus residual. There should not be any pattern. If your model is good, there should not be any pattern for this graph. If you make a plot predicted versus residual. Again, these are the different conditions for checking your model is good or not. Okay. Then again, if you, I think one more graph here. So anyway, here itself I can say, draw the graph by taking actual versus residual. There also should not be any pattern for that graph. Again, you can check, previously I mentioned one point, see, all the variables may not be suitable for prediction of a dependent variable. Okay, for checking that, first you can check the overall performance of your model using a statistical test known as F-test. Overall performance, for example, ma'am, I will finish in 2 minutes. Just not this one. 5:10, I'll finish. Actually, I have been another 5:30, right? Anyway, now 5:10, I'll finish. No, I'm not becoming exciting. Sometime this may be useful to, especially those who are doing project or research. Yeah, see, here, simply I have used that stats package. Okay, using the stats package after developing the model dot summary. So here R square value all are getting. Can you see the F statistic here? Below F statistic you will get a probability value 2.3E05. That means 2.32 into 10 power minus 5, which is purely less than 0.05. If it is less than 0.05, our model is significant. Overall model. Okay, but don't stop with that. Even though you will get overall model is significant, again you can check all the variables are significant or not. Say for example, for that actually we are using t-test. Can you see this? T values. Corresponding to t values, look at this say corresponding to time I am getting 0.0. Probability value is 0. Less than means it is good. But look at this 0.70. Corresponding to temperature I am getting 0.7. That means temperature is not a good variable for prediction of field. So you have to develop a new model by ignoring temperature. Okay? Don't think that, oh, while removing the variable, I am losing that variable, oh, it is. But this significance, while checking this significance, definitely, sometimes you, because no, here actually in this particular example, I am using only 2 variables, but you will be using some more than 20 variables or something like that. So definitely you need to check the significance of each of those estimates. Sometimes you may remove, then develop the new model by ignoring that column. Okay. So like this, lot of methods are there for getting good accuracy or improving your model. Okay. I showed regression only, not only for regression, different machine learning algorithms like this. Lot of theoretical concepts are there behind. Any queries? I know 3 hours, it's not. Actually, be frank, I have not planned a session like this. I have decided, I came here with even I prepared some other PPT. But when I discuss with ma'am, mainly students are here, that's why I just. Anyway, but don't worry, all these things are related to that team. Data analysis, discovery, graphs, inference. All these things are there, whatever algorithms which we choose. Okay, thank you. Any queries? Everyone is actually hurried to leave here. That time asking query. Why ma'am is asking like this? Okay. Keep on for your formalities. Yeah. Normality test or F-test, T-test. Actually, for checking significance, F-test is used for checking overall significance. T-test is used for checking significance of each variable.
Oh, okay.
Whether each variable is good or not. See, suppose you have A, B, C, D, E, F. That much variables. So we are using t-test for checking whether A is good for prediction of your dependent variable, whether B is good or that t-test is the only one which we used. But for using normal t-test, you can choose any of those.
But F-test is what you
Overall model. Overall model. Okay. The other one for individual.
Individual. Thank you.
Okay. Good question. Anyone else?